analyst at globalsecurity.org, who challenged Musk's belief that he could change the fundamental financial equation of putting payloads into low Earth orbit, about $10,000 per pound in weight. Musk responded with ebullient defiance. "But I want to make rockets 100 times, if not 1,000 times better. The ultimate objective is to make humanity a multi-planet species. 30 years from now, there'll be a base on the Moon and Mars, and people will be going back and forth on SpaceX rockets." More hints and details about just how Musk was going to tackle these challenges trickled out over subsequent years, given extra credence by the fact that SpaceX was becoming a respected aerospace company. Musk himself was by the 2010s regarded as a serious space engineer who was raising the pulse and possibilities of spaceflight, while at the same time reducing its costs. Then, in September 2016, Musk made a lengthy SpaceX presentation entitled "Making Humans a Multiplanetary Species." The title promised substantial revelations, and the audience wouldn't be disappointed. Musk opened the presentation with a simple question. "So, how do we figure out how to take you to Mars and create a self-sustaining city? A city that is not merely an outpost, but could become a planet in its own right. Thus, we could become a truly multi-planet species." Working through his set of presentation slides, he next made a scientific case for Mars as the prime objective for space colonization, comparing it to the properties of Earth in a comparative table. In the final row of the table, people, the slide gave the figure 7 billion for Earth and 0 for Mars. One senses that the Mars figure was given to show potentiality for settlement, not resignation to realities. After this, Musk moved on to the economics of Mars settlement. Given that historical spaceflight had been inordinately expensive, this was an important moment in the presentation. How could he do it without burning up entire fortunes? Musk explained that using Apollo-era technology, travel to Mars would indeed be prohibitively expensive at every level, costing about $10 billion per person. At such prices, significant population transfers from Earth to Mars were simply out of the question. Musk then shifted the conceptual framework profoundly. Instead, he argued, he wanted to reduce the per-person cost of going to Mars to about the median price of a house in the USA, about $200,000. Only then could Mars colonization become a genuine off-planet possibility, the decision to move to Mars carrying similar decision-making weight to moving home or having a major change in career. Given the sheer disparity between the $10 billion and $200,000 cost models, clearly some proof was in order. Musk was arguing for a 5 million % improvement in the cost per ton to Mars. Slide 13 of the deck therefore listed the 4 key technological developments that had to occur to achieve this goal. 1. Full reusability. 2. Refilling in orbit. 3. Propellant production on Mars. 4. Right propellant. Any accusations that Musk might have been on a flight of fancy were dispelled in the subsequent section of the presentation, in which he explained the physics, developed theory, and the technologies behind achieving each of the bullet points. The presentation eventually built up to the moment to reveal the system architecture, the actual details of how the Mars missions would be performed, and the types of craft that would make the epic multi-month journeys to the Red Planet. Simplifying somewhat here, the Mars spacecraft would launch from Earth, a huge booster rocket taking the craft into space. The booster would, after separation, return to Earth and make a controlled and autonomous landing, thereafter being reused for subsequent launches. At the beginning of its journey into space, the spaceship would rendezvous with tanker ships, performing an in-flight refueling in the vacuum of space. In an earlier stage of the presentation, Musk explained that not refilling in orbit would require a 3-stage vehicle at 5 to 10 times the size and cost, and also that Spreading the required lift capability across multiple launches substantially reduces development costs and compresses schedules. The tankers then return to Earth while the Mars vehicle now begins its journey to Mars. This epic haul across space would take some 7 to 9 months, traversing about 480 million kilometers, 300 million miles. The spacecraft would eventually make a vertical landing on Mars and offload its passengers and payload. Propellant for the return journey would be manufactured on the planet, the production utilizing materials mined from Mars itself. Musk explained in the slides that bringing return propellant requires approximately 5 times as much mass departing Earth. When the time is right, the spacecraft then makes the return journey to Earth, being turned around quickly for its next flight. The overall vision for reusability is 1,000 uses per booster, 100 per tanker, and 12 per ship. The detail of Musk's Mars ambition goes to the heart of his engineering method, and not least the reasoning from first principles outlined in detail in Chapter 6. At the beginning of the presentation, Musk showed some numinous pictures of Mars and spoke in reverent tones about the possibility that one day we might just live there. At that point in the proceedings, it almost had the ring of implausible 1950s visions of intergalactic travel, more akin to Star Trek than SpaceX. Less than halfway through the presentation, however, Musk has transitioned to an eminently believable prospect, one that possibly can be timetabled into the near future. For Musk, if the logic of the core principles and technologies is sound in the smallest increments, then scaling up to a grandiose scale is equally logical. His ultimate vision does indeed stray into the realms of sci-fi, explicitly so. Over time, there would be many spaceships. We would ultimately have over 1,000 or more spaceships waiting in orbit, so the Mars colonial fleet would depart en masse, kind of like Battlestar Galactica. But it actually makes sense to load the spaceships into orbit, because you have 2 years to do so. The rendezvous orbit for going to Mars comes around every 26 months. An appreciative round of applause came from the audience when Musk finally revealed the instrument of his ambitions, at this stage in its evolution simply referred to as the Mars vehicle. The graphics showed a monster piece of kit, the combined booster and ship standing to a height of 122 meters, 400 feet, even taller than the Saturn V that performed the Apollo missions, at 111 meters, 364 feet. Every statistic about the vehicle represented a leap beyond historical parameters. A 10,500-ton liftoff mass, Saturn V 3,039 tons, a 13,033-ton liftoff thrust, Saturn V 3,579 tons, an expendable low Earth orbit payload of 550 tons, Saturn V 135 tons. Clearly, the Mars vehicle was intended to be a spacecraft that represented the next stage in the evolution of space exploration. Musk reflected on its design, but also made clear that this was just the first step up the evolutionary ladder. It's quite big. The funny thing is that in the long term, ships will be even bigger than this. This will be relatively small compared to the Mars interplanetary ships of the future. But it kind of needs to be about this size because in order to fit about 100 people in the pressurized section and carry the luggage and all of the unpressurized cargo to build propellant plants and build everything from iron foundries to pizza joints, you name it, we need to carry a lot of cargo. The Mars vehicle would eventually acquire a fitting name, Starship. During the 2015 presentation, the slide deck offered a Gantt chart revealing the projected timelines of the mission to Mars. With the major technologies developed by 2019, booster and orbital testing would take place from 2019 to late 2022, and Mars flights themselves would start in the later months of 2022. In reality, these schedules have had to move somewhat. Practical Starship development began in 2019 in Florida and Texas and was accompanied by a stinging commercial decision. In January that year, SpaceX announced that it would be compelled to lay off 10% of its 6,000-strong workforce in order to make the financials work for development of Starlink and Starship combined. The company press release stated, "To continue delivering for our customers and to succeed in developing interplanetary spacecraft and a global space-based internet, SpaceX must become a leaner company." Either of these developments, even when attempted separately, have bankrupted other organizations. This means we must part ways with some talented and hard-working members of our team. The pursuit of Starship would have other significant knock-on effects. In March 2022, for example, SpaceX announced that it was to end production of its Crew Dragon spacecraft, instead focusing future efforts on completing development of Starship. Starship is perhaps the apogee of Musk's space program. In his lifetime, the SpaceX website proudly declares of the ship, "SpaceX's Starship spacecraft and Super Heavy rocket, collectively referred to as Starship, represent a fully reusable transportation system designed to carry both crew and cargo to Earth orbit, the Moon, Mars, and beyond. Starship will be the world's most powerful launch vehicle ever developed, with the ability to carry in excess of 100 metric tons to Earth orbit." The specifications of Starship have changed since the visions of 2015, but only marginally so. And it remains the most powerful rocket ever to lift off from Earth, with the highest payload capacity. Since 2019, the program has evolved from a series of static or short hops to suborbital launches, several of the prototypes being destroyed in the fiery process. But on 5 May 2021, Starship SN-15 successfully completed the first high-altitude test from the Starbase Center in Texas. Starship is not just about Mars. In April 2021, NASA announced that it had selected SpaceX and its Starship to continue development of the first commercial human lander that will safely carry the next 2 American astronauts to the lunar surface as part of its Artemis program. Where Starship and Musk will go in more distant future remains to be seen. Chapter 4: Tesla and the Twitterverse. Electric vehicles, EVs, are not new. Far from it. In fact, EVs are almost as old as the invention of electrical supply and automobiles. Concepts for the development of battery-powered EVs first emerge in the early years of the 19th century. Somewhere between 1832 and 1839, British inventor Robert Anderson put together a 3-wheeled electric carriage, which, powered by a disposable lead battery, could trundle along at a sedate but workable 12 kilometers per hour, 7.5 miles per hour. It was in the second half of the century, however, that EVs started to appear regularly and in significant numbers. In 1881, Frenchman Gustave Trovet unveiled his Trovet tricycle, another 3-wheeled EV powered by 2 engines working off several interconnected lead batteries, giving it a top speed of 18 kilometers per hour, 11 miles per hour, and a range of up to 26 kilometers, 16 miles. In Germany, the Maschinenfabrik A. Flocken Company in Coburg produced from 1888 the 4-wheeled Flocken Elektrowagen, regarded by many as the first true electric car. In 1898, the Belgian EV La Jamais Content, essentially a 4-wheeled metal torpedo with a prominently perched driver, reached a speed of 105.882 kilometers per hour, 65.792 miles per hour, for a short time holding the world land speed record. EVs debuted in the USA in the late 1880s and early 1890s, courtesy of Scottish-born chemist and inventor William Morrison. His work on developing more effective storage batteries led to a self-propelled electrical carriage demonstrator fitted with 24 of his batteries. The vehicle was capable of carrying up to 12 passengers and had a maximum speed of 32 kilometers per hour, 20 miles per hour. Only 12 of these vehicles were made, but the idea was persuasive. By 1900, 38% of all motor vehicles in the USA were electric, compared to 40% steam and 22% gasoline. New York City even had a fleet of 60 electric taxis. Even the likes of Porsche and Henry Ford would either develop or investigate EVs. In many ways, EVs of the early 20th century were superior to the emerging types powered by the internal combustion engine. But, as history now knows, the internal combustion engine won out. From Henry Ford's introduction of the mass-produced Model T in 1908, and with the global expansion of oil extraction, petrol-powered vehicles offered the masses more affordable, convenient, and accessible vehicles. By the 2000s, there would be more than 1 billion such vehicles on the planet. Yet, the pendulum began to swing ever so slightly back from the 1960s and 1970s. Global oil crises, precipitated by conflict in the major oil-producing states of the Middle East, compelled the world to look hard at its vehicular dependence on fossil fuels and to reinvestigate the possibilities of EVs. General Motors, GM, and American Motor Company, AMC, both produced either prototype or small-scale production EVs during the 1970s. Although the core challenge of EVs, limited range, meant that the vehicles remained little more than a thought trial. In the 1980s and 1990s, however, increasing environmental awareness at government level, accompanied by energy and clean air legislation in some countries, including the USA, reconnected the idea of EVs to the engineering grid. GM designed and developed the EV1 and manufactured it between 1996 and 1999. It had a range of 128 kilometers, 80 miles, and acceleration of 0 to 80 kilometers per hour, 0 to 50 miles per hour in just 7 seconds. EVs are capable of delivering more torque than gas-powered cars, hence they often have exceptional acceleration. Battery technologies were also improving. In 1997, Japan's Toyota company released the hybrid electric Prius, powered from a nickel metal hydride battery. Unlike the short-lived EV1, the world's first mass-produced EV, the Prius went on to roaring success. By 2017, more than 6.1 million had been sold. But by this time, there was a powerful new player in the EV market. This competing company would become, by 2022, the true giant of EVs, with a market capitalization of more than $1 trillion and holding 23% of the battery EV market globally, positioned as the leading EV seller by significant margins, even compared against the world's biggest car makers. Founded only in 2003, the company is Tesla, guided by its CEO, Elon Musk. Musk and the EV mission. EVs reflect two central foci within Musk's worldview: energy and environmentalism. Musk's fascination with innovation in electrical energy has deep roots. Remember his absorption in all matters ultracapacitors during his youth, and this intellectual interest has connected with rising concern about Earth's environmental fragility, converting a topic of study into a world-beating company. Musk is certainly not a climate change-denying industrialist. In numerous speeches and writings, he strongly backs the scientific arguments for man-made climate change, which he sees as a threat, if not to humanity as a whole, then at least to the way of life for hundreds of millions of citizens on Earth, especially the 40% of the human population who live on or near a coastline, places most vulnerable to rising sea levels. Fossil fuels lie at the heart of the problem. I mean, there are many important issues in the world. This is not the only important issue, but it is, I think, the thing that will have the biggest negative effect on humanity if we do not address it. In general terms, what is needed to address the climate crisis, and this is the thing that if we do, what actions can we take that will accelerate the transition out of the fossil fuel era? Musk may have built one of the world's biggest car companies, but he is clear-sighted about the link between the consumption of fossil fuels and the decline in our atmosphere. His interest in EVs, therefore, has parallels with his pursuit of space exploration. the technological advancement of both is not just a matter of engineering curiosity or entrepreneurial pursuit, but rather critical parts of the human future. Musk intends to be at the cutting edge of both. With a bit less gravity, however, Musk is interested in electric cars perhaps because another option for solving the fossil fuel crisis, taking people out of their individual vehicles and putting them on public transport systems, is a policy that doesn't exactly fill Musk with enthusiasm. With tongue firmly in cheek, he expressed his views on public transport at a Tesla event running alongside a Neural Information Processing Systems conference in Long Beach, California, in December 2017. "I think public transport is painful. It sucks. Why do you want to get on something with a lot of other people that doesn't leave where you want it to leave, doesn't start where you want it to start, doesn't end where you want it to end? And it doesn't go all the time. It's a pain in the ass. That's why everyone doesn't like it. And there's like a bunch of random strangers, one of who might be a serial killer. Okay, great. And so that's why people like individualized transport that goes where you want, when you want." So, public transport is out. Instead, Musk has focused on 3 primary routes out of the fossil fuel-induced crisis, all of which he has engaged with commercially: battery energy storage, solar power, and EVs. All of these enterprises have been exercised under the Tesla Incorporated brand, but in this chapter, we will focus principally on Tesla as a car maker. The following chapter will delve into solar power, alternative energy, AI, and some of Musk's many other important pursuits. As we have seen from the quick stats at the beginning of this chapter, Tesla has upended the world of car making and selling. In many ways, it is the face of EVs, albeit one in an increasingly competitive market. Like most of Musk's enterprises, it began as a disruptive idea, executed by small groups of people in workshops. The very earliest roots of Tesla were not sown by Musk himself, at least not practically. But it is impossible to argue that the giant EV producer that exists today would not exist in the form it does were it not for his investment, ideas, engineering compulsions, and commercial vision. The relationship between the man and company is an intimate one, not least in the public's eyes. Thus, in this chapter, we will also explore how Musk relates to the worlds of advertising and social media, all of which have been crucial in the historical growth of Tesla. In these areas also, Musk has shaken up the way things are done. As a quick point to illustrate this, Tesla spends $0 on direct advertising, while other car makers often spend hundreds of millions. Why and how this is so, we will explore, but for sure, Musk is a game changer, making his fair share of friends and enemies along the way. The foundations. In total, 5 people are legally regarded as the co-founders of Tesla. They are Martin Eberhard, Mark Tarpenning, Ian Wright, J.B. Strobel, and Elon Musk. The list has not just evolved by common agreement. In fact, in June 2009, Eberhard, once the Tesla CEO, but subsequently removed from the position, filed a lawsuit alleging that Musk had attempted to rewrite history and effectively remove him from both the company and its origin story. Musk pushed back with a vigorous countersuit. The Tesla response, issued by company spokesperson Rachel Conrad, was uncompromising. This lawsuit is an unfair personal attack and, more importantly, paints an inaccurate picture of Tesla's history. This lawsuit is a fictionalized account of Tesla's early years. It's twisted and wrong, and we welcome the opportunity to set the record straight. As the media have already covered exhaustively, Tesla's full board of directors unanimously fired Martin shortly after discovering that the cost of the car was more than twice what Martin portrayed it to be at the time. Incidentally, Tesla will likely be filing counterclaims and, in the process, present an accurate account of the company's history. But in September 2009, the list of co-founders was legally agreed on the 5 names opposite. Clearly, the foundation of Tesla has been a matter of some complexity and acrimony. Tesla was born out of the gradual alignment of several stars. Musk's first practical intersection with EVs was a meeting with a man called J.B. Strobel. Strobel was Musk's kind of guy. He was a lifelong engineer and have-a-go inventor, but with serious intellectual heft. He went on to graduate from Stanford in Energy Systems and Engineering, a major that he essentially developed himself. Strobel was essentially focused on the possibilities of developing clean energy vehicles, even turning a beaten-up old Porsche into an EV that, for a time, held the world record for EV acceleration, then adding hybrid functionality to extend the car's range. While at Stanford, he also labored with a like-minded group of enthusiasts on solar-powered vehicles, and following graduation, he developed some of the world's first gas turbine/electric hybrid vehicles for a company called Rosen Motors, led by engineer Harold Rosen, the inventor of the geostationary satellite, and on developing an all-electric aircraft, also in partnership with Rosen. In the early 2000s, Strobel was particularly fascinated by the possibilities of using lithium-ion, Li-ion batteries, a power source with many advantages over traditional battery types, including a high energy density, a lower self-discharge rate, lower maintenance requirements, higher cell voltages, and greater versatility of application. Rechargeable Li-ion batteries had established themselves in the electronics industry during the 1990s. But Strobel and his solar team friends from university began doing the maths on how thousands of Li-ion batteries could be connected together to provide sufficient power to drive a vehicle. Strobel created a design concept, but just needed someone to invest $100,000 to help him actually build it. Here, Musk enters the picture. Strobel was introduced to Musk by Rosen, and over lunch, Musk bought into the possibilities of Li-ion EVs and agreed to invest $10,000. Strobel also introduced Musk to a Los Angeles-based company called AC Propulsion, founded in 1992 to develop EV technology, especially alternating current-based drivetrain systems, and to provide engineering support to automotive companies. The company had developed prototypes of a sports car EV called the Zero, which included innovations such as regenerative braking and had a dramatic 0 to 60 miles per hour, 0 to 97 kilometers per hour time of 4.07 seconds. They were also working on a far less flamboyant 5-door hatchback EV called the E-Box. Musk was allowed to take the Zero for a spin, loved it, and wanted to invest in taking the vehicle to market. But the offer went nowhere. What it did, however, was galvanize Musk's interest in building his own EV. At the same time as all this was occurring, two California-based engineers were also working on their own development of a Li-ion vehicle. They were Martin Eberhard and Mark Tarpening. Both men were electrical engineers and natural entrepreneurs, and by the time they turned their thoughts to EVs, they had already achieved high success in joint ventures. Together, they had founded Nouveau Media in 1996, through which they developed the world's first e-reader, known as the Rocket eBook. Although the Rocket eBook would not survive long into the 2000s, Nouveau Media itself was bought in 2000 by Gemstar TV Guide International for $187 million. So, the pair of entrepreneurs now had money to invest in other projects. Like Musk, Eberhard also had a go at turning AC Propulsion into the model of where he wanted to go with electric vehicles. But when that didn't work out, they decided to form their own company. It was founded on 1 July 2003, the name of the company inspired by the legendary Serbian-American engineer and inventor. It was called Tesla Motors. The industry. Before we march on with the Tesla narrative, some context is required both to understand the obstacles Tesla would face as an automotive startup and to appreciate what Musk and his team have done with the company and its products to date. For generations, most of the vehicle marques we see around us have been predictably familiar: Ford, BMW, Toyota, GM, Jaguar, and so on. The principal reason for this limited batch of car manufacturers is that the financial and production barriers to enter the market are so extreme if you want to be more than a small bespoke car builder. The industry costs associated with the development of a new car, from initial concept through R&D, prototype construction, testing, and eventually arriving at the production design, commonly range between $1 billion and $6 billion, depending on the level of innovation or reuse from previous vehicles. The development process involves hundreds of engineers working at costly and often exclusive facilities with massive fixed costs. Then there is the matter of manufacturing, involving vast production plants, thousands of factory floor employees, armies of robots, thousands of tons of raw materials, hundreds of thousands of components, plus shipping from distant destinations. Once a car rolls off production, it also has to be sold at a profit, in a brutally competitive market, deeply subject to the vagaries of major economic shifts. Profit margins for new cars vary profoundly according to the manufacturer and prevailing market conditions, but tend to be in the 10 to 20% range, although the net profit of major car makers all told is typically single digits or a loss. The message appears simple. If you want to enter the automotive business, you ideally need billions in the bank, a huge engineering and manufacturing infrastructure, and a compelling product. Even scale has been no protection. Many of the world's largest car makers have slid into bankruptcy proceedings, some emerging from the other side in revamped form, but many not surviving. But Musk sees things differently. In a tweet in March 2021, he made a deep claim. Tesla and Ford are the only American car makers not to have gone bankrupt out of thousands of car startups. Prototypes are easy. Production is hard, and being cash flow positive is excruciating. Based on his experience of Tesla, he was right on every count. From investor to CEO. Given the towering walls blocking mass car manufacture, Eberhard and Tarpening's ambition for Tesla was focused on developing a vehicle for the upper end of the market, targeting affluent individuals who had embraced the eco-future and who wanted a sports car that expressed both their fashionably rich status and their environmental credentials. It was a canny positioning, and one that Musk would eventually continue. In terms of a future cascade to more mass-produced vehicles, the initial car would hopefully provide the seed money to introduce new models at greater economies of scale. As wealthy as they were, Eberhard and Tarpening did not have the R&D resources to develop a brand new car from scratch, so they were on the scout for ways to streamline the process. The initial plan was to license the power plant technology developed by AC Propulsion and marry it to the chassis of the elegant Lotus Elise. The chassis would have to be stretched by 127 millimeters or 5 inches to accommodate the EV components. Then, instead of selling the car through dealerships, they would instead create a publicity buzz around the vehicle and sell direct to the consumer. The plan was savvy, but even though they were looking to bypass swaths of traditional development costs, building a prototype was still going to be an expensive process. They needed investors. Elon Musk now re-entered the stage in earnest. The three men met in LA to discuss the proposition, and Musk bought into the plan. He invested $6.5 million in creating the Tesla EV. The size of the investment made Musk the largest shareholder in the company and gave him the position of company chairman, two factors that might have seemed secondary at the time, but which would become of signal importance later on. For now, the men set to work building a car company. A team of talented engineers was brought together and a workshop facility bought and set up in San Carlos, San Mateo County, California. Musk quickly drew Strobel into the company, tasking him with developing the truly critical component of this vehicle, the battery storage pack. We must remember that Li-ion EV power plants were still in their experimental infancy at this stage. Strobel and those who helped him would be at the genuine cutting edge of clean energy technology. There was much riding on their talents and innovations. Despite an extremely basic workshop, certainly in comparison to those of the large car makers and a team of just 18 people, Tesla pulled off the incredible feat of designing a working prototype between October 2004 and January 2005, due in part to their light and quick management processes. The new car would be called the Roadster. Musk, having taken the vehicle for a test drive, was encouraged both by the product and the progress and put an additional $9 million of his own money into the car. In 2006-2007, furthermore, Musk pulled in $105 million from tech-hungry venture capitalists and investors wanting an early slice of the cake. They included Valor Equity Partners, Draper Fisher Jurvetson, Google co-founders Sergey Brin and Larry Page, Compass Technology Partners, and former eBay president Jeff Skoll. Arrival at prototype stage, however, still left a long, winding, and arduous road ahead. There were endless engineering challenges with the new technology, such as how to control heat buildup and how to prevent fires in thousands of individual but connected batteries. The final production Roadster would contain 6,831 batteries in each unit. The total weight of the battery was about 454 kilograms, 1,000 pounds. Another significant change was that it was decided to move away from the Elise body and create something far more bespoke to the Tesla brand, made out of carbon fiber. Looking back through early Tesla press content, Tesla was keen to break the widespread idea that the production Roadster was nothing more than an electrified Elise. In a two-part Mythbusters blog in March 2008, Daryl Seary, the vice president of sales, marketing, and service at the company, acknowledged that one of the more common misconceptions about the Tesla Roadster is that it is an electrified Lotus Elise. He went on to explain that the Tesla actually only had a 7% parts share with the Elise. So, you could say that the Tesla is similar to a Lotus Elise, except it has a totally different drivetrain, body panels, aluminum tub, rear subframe, brakes, ABS system, HVAC, and rear suspension. The Tesla also neglects to carry over the gas tank, emissions equipment, and exhaust. If you were to try to convert an Elise to a Tesla and started throwing away parts that aren't carried over, what you would basically be left with a windshield, dashboard, complete with airbags, front wishbones, and a removable soft top. By now, Musk himself was heavily involved in the design process of the new car, making regular contributions to the features and layout of the vehicle. He was also getting the publicity machine into full swing, creating a crackle of excitement about the vehicle that was about to hit the scene, a previously improbable fusion of Silicon Valley know-how, conspicuous consumption, high-end performance, and environmental awareness. The car had its initial unveiling to the public on 19 July 2006 at an invitation-only event in an aircraft hangar at Santa Monica Airport. Some 350 celebrities, business leaders, and media movers and shakers attended to see the second Roadster prototype, EP2, on display. The technical issues the engineering teams were still wrestling with were not up for discussion. Instead, the audience was presented with a $90,000 car with a 0 to 60 miles per hour of 4 seconds, a range of 400 kilometers, 250 miles, and all the bells and whistles features one would expect of a supercar. Musk pumped up the product, emphasizing that, until today, all electric cars have sucked. Pre-orders flooded in, and the media were getting excited. But back in the workshop, all was not well, at a serious scale. Tesla was undoubtedly a company challenging the traditional routes of developing and building a car. It found maverick ways to bypass some of the stinging costs of R&D. For example, instead of taking the Roadster prototypes to a high-cost industry facility for sub-zero testing, they simply bought and converted a freezer lorry. But the problems and the associated delays mounted as they attempted to take the Roadster into production and full launch. There were serious technical issues with the transmission, which was found to be failing at a mean average of about 3,200 kilometers, 2,000 miles. A battery production plant being built in Thailand was, at least initially, disastrously unfit for purpose. There was a complex international production system with body panels made in France, power units in Taiwan, battery packs in Thailand, the parts having been shipped in from China, then shipped to England, with Lotus assembling the body of the car and installing the battery packs in the UK, after which the Roadsters eventually shipped to the USA. Vance 2015-173. Things were starting to get out of control, especially as investors' money was being spent at an alarming rate. There were also tensions at the top. According to Vance, Tarpening said Musk was livid when a New York Times profile of Tesla focused more on Eberhard and the car than they did on Tesla's biggest shareholder. Vance 2015-167-68. Matters were made worse by what Eberhard allegedly saw as Musk's frequent interference with vehicle design. Eventually, matters reached a peak. Valor Equity sent its astute and experienced managing director of operations, Tim Watkins, to analyze what was happening at Tesla. He came away with a dreadful picture of mounting chaos, the problems including runaway costs, poor financial management, failures in vehicle functionality, and major supplier issues. By his calculations, Tesla would actually lose about $115,000 per vehicle. Vance 2015-175. Once Watkins made his report to Musk and the board, there was a move to make a change at the top. In August 2007, Eberhard lost his position as CEO. To be fair, according to Vance, Eberhard had been asking for this anyway, and instead became president of technology. Tarpening was vice president of electrical engineering. Board member and manufacturing logistics expert Michael Marks temporarily stepped into the CEO role and sought to bring more organizational order to Tesla production. In December 2007, Marks was replaced by entrepreneur Zev Drury. Notably, both Eberhard and Tarpening left Tesla altogether in January 2008 and on decidedly poor terms with Musk. The following October, Musk himself stepped up and became the Tesla CEO. In 2008, as we saw in the previous chapter, the world seemed to decide to stack itself up against Elon Musk. Energized by Musk's aggressive and involved style of management, Tesla managed to put the Roadster into production. At the same time, another vehicle, known provisionally as the White Star, was under development. This would become the Model S, a five-door sedan aimed at widening Tesla's market from upper-end sporting luxury to mid-range family car. The Model S, as it turned out, would be both the salvation and the making of Tesla. But that was some way in the future. Back in 2008, Tesla was hemorrhaging about $100,000 per day, and even though more than 1,000 Roadsters had been reserved, production and quality issues meant that only 50 had been delivered. Press skepticism about the upstart company was mounting. Above all, Musk needed money to survive as the coffers began to run dry. Bankruptcy soon looked likely, not an outside possibility. Musk's round-the-clock efforts to save his companies are now the stuff of legend. He went to every source he could find, investors, employees, friends. He put in his own money and sold quantities of his shares in Solar City. See the following chapter for more about this company. A lifeline was thrown when one of Musk's own investments, Everdream, a company that provided remote office and data services founded by Musk's cousins, see Chapter 5, was bought by Dell Computers in a $340 million acquisition, which gave Musk a sudden $15 million windfall to plow straight back into Tesla. SpaceX provided Tesla with loans, although as we saw in the previous chapter, the financial struggles to enter the space race were also exacting a cost on Musk's finances. But it was still not enough. And as Christmas 2008 approached, Musk had just weeks of payroll funds left. Arguably, the worst moment of a terrible year came in early December, when a deal for Vantage Point Capital Partners to match the $20 million Musk himself had raised suddenly hit a block, as the investors questioned the valuation of Tesla. According to Vance, Musk began to suspect that the venture capital firm was attempting to make maneuvers to take ultimate control of Tesla, and possibly sell it off to one of the big car makers. Under intense pressure, Musk held his nerve, even claiming that he would fund Tesla himself from another SpaceX loan. On Christmas Eve, literally a matter of hours before Tesla would have folded, Musk won the staring contest, and the funding came through. For now, Tesla was still a going concern. It was far from out of the woods, not least because there remained many technical issues with the Roadster, which Tesla was spending time and money to resolve. In 2004, Tesla had estimated that the Roadster would cost $25 million to develop. By 2008, it had actually cost $140 million, although that was still way below anything that could be achieved by the wider automotive industry. Musk drove his team on unrelentingly, and was ever making demands on cost, schedules, and quality that, to many, seemed like impossibilities. It has been noted by some of Musk's executives, however, that a person who said something was impossible would often be fired. Then Musk would take over the job personally and deliver exactly what his employee had claimed was undoable. And then the sales began to mount. By the scale of the big car makers, the Tesla sales figures were not huge by any score. 147 cars went out in January 2009 and 2,500 between 2008 and 2012. But remember that these were years of global financial crisis, when hundreds of companies were going to the wall and hundreds of thousands losing their jobs. Tesla was not only surviving, but in its way was showing signs that it might be able to thrive, and with a groundbreaking new product. The company again became hot property for investors. The breakthrough. The Roadster would not, however, be Tesla's breakthrough car, not least because Roadster production ceased in January 2012. It would make way for the second of Tesla's offerings, launched 6 months later, the Model S. The Model S was an evolutionary next step for Tesla. It was still a luxury vehicle, but instead of a sports car, it was to be a high-quality 5-door sedan, sold around the $50,000 to $70,000 mark, but again, with all the performance, economy, and environmental advantages of a Tesla EV, plus a range of high-tech features that would make the vehicle a compelling proposition. The path to production was paved with complications, obstacles, and battles. Getting the design and functionality to Musk's bar-raising specifications was a profound challenge for his team. In terms of the overall look, the task was originally handed to Danish-American automotive designer and entrepreneur Henrik Fisker, who had previously worked for BMW, Ford, and Aston Martin, as well as running his own engineering company, Fisker Coach Build. His initial designs were not received well and were regarded by many in the company as uninspiring. Then, in 2007, Fisker left to establish his own design company, Fisker Automotive, and in 2008 unveiled the Fisker Karma, a hybrid luxury sports car, later all-electric, of outstanding beauty. This led to Tesla filing a lawsuit against Fisker, saying he had stolen design ideas while working under Tesla's coin, although Fisker ultimately won the case against him. In Fisker's place came Franz von Holzhausen, previously of Volvo, GM, and Mazda, a talented man looking to find creative liberty away from the corporate layers of the big car makers. Operating out of a workshop placed within the SpaceX factory, von Holzhausen and a small team of engineers created the layout and look of the Model S in about 3 months flat. But Musk was never far away, and his scrutiny was laser-like. There is much of Musk in the Model S. Every contour, every button, every device, every feature, nothing escaped his view. After each minor round of improvements, he would view or drive the vehicle and come back with a long list of improvements reportedly logged in his memory rather than on paper. He would reel off the required amendments to his subordinates, and when the car was presented back to him following further work, Musk would remember each item of concern and note whether it was resolved to his satisfaction. Innovation oozed out of the vehicle, exterior and interior. Instead of the typical car dashboard, it would feature only a large 43-centimeter, 17-inch central touchscreen computer, fully Internet-enabled, a feature that had never before been tested or installed for vehicular use. The door handles retracted when not in use. One of the biggest innovations was the body, which Musk decided should be made out of aluminum rather than steel, thereby offering a considerable weight saving, increasing car and battery performance, but far harder to work into a car body. After a protracted period of exhaustive refining, the Model S was finally unveiled in March 2009. Packed with groundbreaking technology and unheard-of service support, see below, the new car seized the attention not only of the media, which gave ebullient feedback, but now also of the big car makers, many of which had been treating Tesla with patronizing dismissal. Some embraced Tesla's innovation, particularly Daimler AG, owner of the Mercedes-Benz brand, which acquired a 10% stake in Tesla for a $50 million investment. Tesla would go on to develop battery pack and charger technologies for Daimler vehicles. Note that Tesla had used the Mercedes CLS as a baseline in their development of the Model S, but Tesla still faced the problem of how to build the vehicle in sufficient volume. In short, it needed a factory and all the kit that went in it, but that was going to cost huge money. Two breakthroughs solved the problem. First, Tesla, particularly through the efforts of Diarmuid O'Connell, the supremely capable vice president of business development, managed to secure in June 2009 a $465 million loan from the U.S. Department of Energy, part of the $8 billion Advanced Technology Vehicles Manufacturing Loan Program. The money was intended to help build a new factory, but another fortuitous opportunity arose. A giant car assembly plant in Fremont, California, constructed in the 1980s as a joint venture between GM and Toyota, suddenly came on the market, as GM filed for bankruptcy the same month that Tesla won the government loan. A large part of the plant, which included all the build technologies and had 5,000 unemployed workers to draw on, was bought by Tesla for just $42 million, and Toyota took a 2.5% stake in Tesla for a $50 million investment. All the pieces of the jigsaw were falling into place, but further fundraising was required to give the Model S the best chance possible. On 29 June 2010, therefore, Tesla became a public company with an IPO on NASDAQ. It was the first time that a U.S. car maker had issued an IPO since Ford in 1956. Despite some negative press analysis before the IPO, based on the heavy losses and costs Tesla had incurred over previous years, the IPO was a resounding success, issuing 13.3 million shares at $17 a share and raising $226 million. The share price would increase 41% by the following day, and by the following July, it had hit an astonishing $130. The Model S has become one of the great automotive success stories in modern history. The latest battery pack features some 7,920 battery cells and, depending on the model, can deliver a range of between 401 kilometers, 249 miles, and 647 kilometers, 402 miles, on a single charge. The battery itself is at the cutting edge of electrical storage with the addition of silicon alongside conventional graphite in the anode, increasing the energy density. Were the Model S a conventional petrol-powered vehicle, it would be doing more than 160 kilometers, 100 miles per gallon. The battery, the heaviest component of the car, is located between the axles, which gives the vehicle exceptional stability on the road. All the models are fast, the P100D being exceptionally so. It has an astonishing 0 to 60 miles per hour time of 2.28 seconds, which for a while made it the fastest production vehicle in the world. Almost everything is digitally controlled by the central touchscreen, which has 24-hour internet connectivity. The connectivity brought a real customer value. If there was something wrong with the car's performance or functionality, customers would report it to Tesla, and then Tesla engineers could log into the vehicle remotely and make the fix directly in the car's software, sometimes while the customer slept. The system could also automatically navigate the driver to any Tesla charging station. The innovations in the Model S kept on coming, and suddenly the big car makers seemed like lumbering dinosaurs, stumbling behind Tesla and trying to catch up. Musk's company also began building charging stations around the USA, these offering free charging to Tesla customers. For a time, Tesla would also offer a 90-second battery swapping service at the charging stations, although that idea was eventually dropped, and 480-volt Tesla supercharger stations offer the fastest way to charge Tesla vehicles. What was truly astonishing about the Model S was some of the press plaudits. A review of the early production car by Consumer Reports gave an astounding review. "This car performs better than anything we've ever tested before. Let me repeat that. Not just the best electric car, but the best car. It does just about everything really, really well." Similarly, in 2019, the magazine Motor Press declared that the 2013 Model S was not only the car of the year, but also the superior vehicle of all the cars of the year over the magazine's 70-year history. World beater. With the Model S, Tesla's commercial trajectory banked sharply upward, but it went into an even steeper climb with the addition of subsequent models. The original logic of Tesla, that the sales of high-end vehicles would ultimately fund the development and production of more mass-market EVs, held good. In September 2015, the company launched the Model X, a mid-sized luxury sedan, partly based on the Model S, but with the standout feature of falcon wing doors, a term coined by Musk. The doors, on opening, rise up and then flatten out, and were designed, on Musk's visions, primarily to provide easy access for parents trying to get kids or shopping in the back seats, even with cars parked tightly on either side or with low garage ceilings. But the real game-changer was the Model 3 compact sedan, which went to market in July 2017. Here was a true mass-market car, relatively affordable on middle-class budgets, but offering all the unique qualities of a Tesla EV. Early press reviews were enthusiastic, seeing it as a new option to those otherwise tempted by a mid-range BMW, Audi, or Mercedes. The car was unveiled on the morning of 31 March 2016, and within 2 days, Tesla had 232,000 reservations. Within a week, that figure had risen to 325,000. Once production issues were overcome, the Model 3 went on to become the world's best-selling EV. In August 2021, some media sources calculated that more than 1 million Model 3s had been sold. Furthermore, by this time, Tesla had another best-selling model available, the Model Y, a compact crossover unveiled in 2019, with deliveries beginning in 2020, offering a less expensive option than the Model X. Observant readers might have noticed that the Model S, X, and Y nearly spell the word sexy. This apparently was intentional on Musk's part. The E was taken when Ford blocked Tesla's use of Model E, saying it was too similar sounding to Ford's original Model T. Tesla's Model 3, therefore, is essentially a Model E with the E reversed to a 3. Model Y sales climbed past the $500,000 mark by the end of 2021. But before we think that Musk was slipping into becoming a conventional car CEO, we will now take a moment to explore another way in which Musk has challenged the outlook of an entire industry forever. Musk as marketer. In May 2019, the digital marketing consultancy Brand Total produced a report analyzing the social media spend of some of the world's biggest car companies: Toyota, BMW, Honda, Audi, Ford, Infiniti, Cadillac, Porsche, and Tesla over a 30-day period. One of the standout conclusions of the report was that while almost all the car companies were spending heavily on paid advertising across the 4 major social media platforms, Facebook, YouTube, Instagram, and Twitter, Tesla was paying precisely $0. And yet, despite its complete lack of monetary ad investment, Tesla still had 2 million organic engagements on social media, only behind Porsche, which had 2.2 million, although they were a mix of both paid and organic. If we take the analysis back to 2015, other patterns emerge. According to a report by Global Equities Research for that year, Tesla's ad spend per vehicle sold was just $6. Not yet zero, but still laughably meager. Note how this compared to some other major manufacturers. Toyota, $248. Honda, $258. Porsche, VW, $267. Cadillac, General Motors, $1,163. Lexus, Toyota, $1,168. Fiat Chrysler, $2,158. Lincoln, Ford, $2,550. Jaguar, $3,325. Hanley, 2016. Obviously, there are major differences in the sizes and competitiveness of the markets the individual car makers contest, but the gulf between the Tesla costs and those of other makers cannot purely be reduced to these terms. As in almost all his other business models, Elon Musk is a disruptor in advertising, largely because he has found powerful ways to avoid paying for publicity. This is astonishing when framed with industry comparisons. In 2019, the year of the Brand Total report, Ford spent $3.6 billion, Toyota $1.5 billion, and the relatively restrained BMW $300 million on advertising. It is worth asking, therefore, how Musk is transforming the model. Historically, Musk's capabilities as a marketer have divided opinion. In the Zip2 and PayPal years, Musk's marketing was seen by many, inside and outside his companies, as rather hot-headed, making dramatic promises of launch dates and service breakthroughs that often stretched beyond the realities of delivery. This has remained a criticism of Musk to this day. But what was certain was that Musk could create a buzz about his businesses in a way that few others could. Musk is a prime exponent of what we today call CEO-led marketing, the personality, insights, and promises of the leader being used to drive product information, create customers, and generate buzz and viral energy within the digital media domain. Musk's undoubted dynamism, adventurism, and innovation, in addition to his involved personal life and celebrity status, have generated a mass following of adoring fans, known as Musketeers, a dynamic and enthusiastic community through which Musk can deliver his marketing interactions. Note that Musk has more than 81 million followers on Twitter, only marginally fewer than Lady Gaga, Ariana Grande, and Taylor Swift. Musk is an active and frequent tweeter. He genuinely engages with his followers, answering questions, leaving teasing hints of what is to come, connecting with people across all walks of life, but especially those with the same appetites for technology, innovation, and entrepreneurship. An article in BusinessInsider.com by Mark Matusik, published shortly after the Roadster sailed past Earth for the cameras, recognized Musk's accessible voice on social media. Musk has also shown a gift for building excitement through social media. He is one of the few CEOs with a Twitter account that doesn't feel as if it's written by a public relations team, and his candor is both endearing and effective. He responds to questions and concerns from Tesla customers, teases upcoming features, and cracks jokes, generating a significant amount of news coverage for his companies. Furthermore, the content Musk talks about on Twitter is exciting, varied, and charismatic. 1 minute chatting about his general thoughts on success or literature, the next probing obscure corners of aerospace engineering or physics. It is a lively and dynamic sphere, one equally electrified by Musk's celebrity. People are interested not only in what he does, but also in what he thinks, how he behaves, what he buys, what he reads. Then there are Musk's big, demonstrative acts of marketing, the ones that set social media alight. At the summit of these is, surely, the launch of the Tesla Roadster into space in 2019, mentioned in the previous chapter. We should not see this moment purely as an expression of audacity gaining publicity through shock and absurdity. Mark Winnick, in Advertising Aged, declared that Musk was miles ahead of the rest in reaching a younger demographic, acknowledging that where mere mortals scrabble about spending millions to fight each other over seconds of airtime, Musk just executes his vision. But the Roadster launch also accrued many column inches in specialist space, technology, and automotive magazines, heightening awareness of topics such as space exploration, the future of electric vehicles, the potential of autonomous technologies, all while attaching the Musk brand to the ideas. As so often with Musk's marketing, the media follows the conversation he creates and effectively does the marketing for him. However, we should be careful about attempting, as many have done, to distill the Musk method of advertising and marketing, although there are certainly valuable lessons to be learned. I think the error is one of focus. While Musk certainly understands the power of social media and viral publicity, he also appreciates that ultimately it is customer satisfaction with the product that drives the success story. If the product is inferior, it ultimately won't gain commercial traction, no matter how much buzz you might attempt to generate around it. The $0 ad spend at Tesla is not because money doesn't need to be spent on marketing, but the best marketing investment is to create a product people love, as Musk outlined in a TV interview. What we really focus on in Tesla is we put all the money into and attention into trying to make the product as compelling as possible, because I think that really the way to sell any product is through word of mouth. So if somebody gets the car, they really like it. Actually, the key is to have a product that people love, and generally people, if they're at a party or talking to friends or whatever, you'll talk about the things that you love. But if you just like something, it's okay, you're not going to care that much. But if you really love it, you're going to talk, and then that will drive word of mouth. And that's basically how our sales have grown. We don't spend any money on advertising or endorsements, so if anyone buys our car, they just bought it because they like the car. We could perhaps make a parallel between Musk's focus on product development and Jeff Bezos's extreme customer focus. Both essentially come from the same angle of attack. Make the customer happy first and foremost, whether with a product or a service, and to a large degree, the rest will take care of itself. Musk, the Twitterverse, and politics. For Musk, Twitter has been one of the key tools in his extraordinary marketing power, giving his voice a deep and broad reach into an ever-growing army of loyal followers, while enticing business leaders, analysts, and the media with cryptic hints of future plans. But the mass influence he wields through Twitter has been questioned and challenged from several quarters, not least the U.S. government itself. On 7 August 2018, Musk tweeted the following message: "Am considering taking Tesla private at $420. Funding secured." Given that Musk had taken Tesla public just 8 years previously, this was clearly major news, albeit broken through a rather informal channel for its import. The same day, Musk sent a lengthier email to his employees spelling out his financial vision for the company. As always, such documents open additional windows of understanding onto how Musk operates as a businessman. He explained to his employees that a final decision has not yet been made, but the reason for doing this is all about creating the environment for Tesla to operate best. He first set the context, outlining his view that Tesla was a company with its strategic eye on distant horizons, and the wild swings in our stock price that can be a major distraction for everyone working at Tesla, all of whom are shareholders. Musk further explained that being a public company makes Tesla more beholden to performance within a quarterly earnings cycle, rather than to more considered future goals. I fundamentally believe that we are at our best when everyone is focused on executing, when we can remain focused on our long-term mission, and when there are not perverse incentives for people to try to harm what we are all trying to achieve. He also pointed to SpaceX as the perfect example of the efficiencies that can be attained by a privately owned company. In the second, lengthier part of his email, Musk laid out in detail what this all meant for Tesla employees. He had no intention of merging Tesla and SpaceX. He also iterated that the possibility of taking Tesla private has nothing to do with accumulating control for myself. He stated that taking the company private would have little effect on his current 20% ownership of the company. He signed off. A private Tesla would ultimately be an enormous opportunity for all of us. Either way, the future is very bright, and we'll keep fighting to achieve our mission. According to the email, only a shareholder vote stood between opportunity and reality. Within this email, therefore, Musk's habitual perspectives are reinforced, keeping focus on the long-term vision, putting product development above short-term financial considerations, not allowing external pressures to distort long-term development. It was persuasive stuff. One organization that was definitely not impressed with Musk's tweet, however, was the U.S. Securities and Exchange Commission, SEC. This venerable instrument of the U.S. government exercised a three-part regulatory mission, in its own words, to protect investors, maintain fair, orderly, and efficient markets, facilitate capital formation. As markets reacted to the Musk tweet, the SEC fired up a complaint and investigation against Musk on the following grounds. The SEC's complaint alleged that, in truth, Musk knew that the potential transaction was uncertain and subject to numerous contingencies. Musk had not discussed specific deal terms, including price, with any potential financing partners, and his statements about the possible transaction lacked an adequate basis in fact. According to the SEC's complaint, Musk's misleading tweets caused Tesla's stock price to jump by over 6% on August 7 and led to significant market disruption. The SEC was tacitly recognizing the market influence that even a single tweet from Musk can exert. The following September, Musk and the SEC came to a settlement, with neither Musk nor Tesla either admitting or denying the charges. But the terms of the settlement were severe. 1. Musk will step down as Tesla's chairman and be replaced by an independent chairman. Musk will be ineligible to be re-elected chairman for 3 years. 2. Tesla will appoint a total of 2 new independent directors to its board. 3. Tesla will establish a new committee of independent directors and put in place additional controls and procedures to oversee Musk's communications. 4. Musk and Tesla will each pay a separate $20 million penalty. The $40 million in penalties will be distributed to harmed investors under a court-approved process. As part of the third bullet point, according to press reports, lawyers would scrutinize Musk's tweets before they were posted in order to ensure that they conformed with the settlement requirements. But as time would show, this was by no means the end of the struggle between the SEC and Musk. Musk has described himself as a free speech absolutist. Notably, this phrase was used in a tweet posted on 5 March 2022 during the opening weeks of the Russian invasion of Ukraine, in which Musk argued, "Starlink has been told by some governments, not Ukraine, to block Russian news sources. We will not do so unless at gunpoint. Sorry to be a free speech absolutist." For Musk, the preservation of people's ability to say what they think is sacrosanct. Thus, following the settlement with the SEC in 2018, many were interested to see how the conditions would affect his Twitter activity. From the user's point of view, not too significantly. Musk has continued to muse and reflect freely, and this brought continuing friction with the SEC. In February 2019, the SEC accused Musk of contempt of court by tweeting about expected Tesla production figures without first seeking the approval of company lawyers, a charge that Musk countered angrily. Relations between Musk and the SEC went even lower, Musk referring to the SEC as the Short Seller Enrichment Commission in another tweet for October 2018. Then, in November 2021, the SEC issued a subpoena to Tesla seeking information about governance processes around compliance with the SEC settlement as amended. On 17 February 2022, Musk and Tesla pushed back more forcibly. Musk's lawyers issued a legal complaint against the SEC, stating that the government agency had gone beyond the pale, accusing the body of failing to pay Tesla shareholders the $40 million it had collected from the 2018 settlement, and arguing that the SEC has been devoting its formidable resources to endless, unfounded investigations into Mr. Musk and Tesla. In a subsequent letter, the SEC defended itself against the accusations, saying that it was behaving consistently in line with the expectations of the 2018 agreement. As I am writing this book, the tension between the SEC and Elon Musk shows little sign of abating. On 11 February, a contributor to Musk's Twitter, Earl of Frunk Puppy, posted a comment. Tesla drawing attention from the CDFEH, California Department of Fair Employment and Housing, NHTSA, National Highway Traffic Safety Administration, SEC, and CADMV, California Department of Motor Vehicles, all at the same time because they are upsetting unions, legacy auto, the oil industry, and autonomous driving companies, and not paying for ads or buying politicians. To which Musk replied succinctly, "Exactly." This situation perhaps reflects an almost inevitable conflict between powerful private individuals and the government, a relationship that oscillates erratically according to the political colors of the administration in power and the public leverage of the business leader. Musk is undoubtedly one of the planet's most influential private citizens and is likely to remain so for the foreseeable future. His core interests overlap squarely with many of those of the U.S. government and international polities: space, transport, finance, energy, culture, and thus he will be forever under the government spotlight. Although Musk is a driven entrepreneur and, like most entrepreneurs, doesn't appreciate political roadblocks dropped across the path of progress, it would be lazy to characterize him as a simple freewheeling capitalist. Musk's political views, if they can be discerned, appear nuanced and pragmatic, rather than visibly aligned in one particular direction. From the public statements he has given, he appears largely centrist in outlook, describing himself as half Democrat, half Republican, and pro-democracy but with socialist sympathies. But he certainly understands the importance of access to political movers and shakers. In 2012, the Sunlight Foundation, the nonprofit research organization advocating open government, published a report exploring Musk's political contributions. It claimed that since its foundation in 2002, SpaceX had spent more than $4 million lobbying Congress and given more than $800,000 in political contributions. In November 2021, CNBC reported that SpaceX and Tesla had spent more than $2 million on lobbying since the beginning of 2021. The author is unable to verify these claims, but perhaps attempting to do so is not the smoking gun it might seem to be. Given the nature of Musk's projects and businesses, some degree of political buy-in is essential to the realization of his work. This is not an argument in favor of untrammeled and egregious political lobbying, but rather an acceptance that given Musk's domains, it would be hard to see how seeking government understanding and support could not be involved at some level. The levels of political access are highly variable, however. At the time of writing, for example, relations between Musk and President Joe Biden seem to have hit rock bottom. Musk has made repeated complaints that President Biden has largely avoided referring to Tesla in any discussions of the electric car market, despite Tesla being the largest manufacturer of EVs in the USA by a huge margin. By 2020, about 80% of EVs manufactured in the USA came from Tesla factories. In August 2021, President Biden invited executives from General Motors, Ford, and Chrysler, collectively known as the Big Three car makers, to a signing ceremony of an executive order urging that U.S. auto manufacturers produce more EVs. Musk and Tesla were not invited, a decision about which Musk commented, "Yeah, seems odd that Tesla wasn't invited." Musk subsequently argued that this situation was especially curious given that GM sold just 26 electric vehicles in the fourth quarter of 2021, a quarter in which Tesla sold 308,600 of an annual total of 936,172. The political logjam seemed to be broken on 6 April when Biden administration officials met with Musk and other automotive leaders to discuss electric vehicles and charging infrastructure. All this being said, when it comes to matters of the economy specifically, Musk appears to like the government to stay in its proper lane. In the following quotation, given during a TV interview, Musk provided a neat definition of what that lane should be and where government could be served. "I'm generally a fan of, minimal government interference in the economy. The government should be kind of like the referee, but not the player, and there should not be too many referees. But there is an exception, which is when there's an unpriced externality such as the CO2 capacity of the oceans and atmosphere. So, when you have an unpriced externality, then the normal market mechanisms do not work, and then the government's job is to intervene. And the best way to intervene is to assign a proper price to whatever the common good is that's being consumed, and that there should be a tax on carbon, if the bad thing is carbon." Musk recognizes here that some crucial issues facing humanity sit outside the purview of market forces, and of necessity need to be handled by national governments. But overall, Musk sees it as important for the government to rule its people with a light touch, staying out of the daily operations of lives and businesses. He put it succinctly in a tweet on 2 December 2021. "In general, I believe government should rarely impose its will upon the people, and, when doing so, should aspire to maximize their cumulative happiness. That said, I would prefer to stay out of politics." Musk might prefer to stay out of politics, but we have already seen how difficult that is, not least because even the briefest of his tweets can spark the most intense speculation and media interest. Musk certainly understands the waves his Twitter account can set in motion. On 14 March 2022, in an announcement that sent an earthquake through the media landscape, it was revealed that Musk had purchased nearly $3 billion worth of Twitter stock, making him the largest shareholder in the company with a 9.2% share. The day after the revelation, Twitter's CEO, Parag Agrawal, then disclosed that Musk had been invited onto the company's board of directors, an offer that apparently Musk accepted. Then came an abrupt about-turn. On 11 April, Agrawal explained in a tweet that Elon has decided not to join our board. The tweet also posted the letter sent to unsettled Twitter employees, and while it gave no detail about the decision, it did state that Elon is our biggest shareholder and we will remain open to his input. After news of the U-turn broke, Musk put out a cryptic tweet consisting of nothing but a hand-over-mouth emoji. The media went into overdrive in its interpretation of events. One crucial factor in the mix, and possibly the driving force behind Musk's investment, was that Musk had publicly hinted at a dissatisfaction with Twitter's direction. In a tweet of 5 April, Musk stated how he was looking forward to working with Parag and Twitter to make significant improvements to Twitter in coming months. Some of the potential improvements, according to media trawling of Musk's earlier Twitter comments, some of which were subsequently deleted, appeared to include making Twitter ad-free, converting the San Francisco headquarters into a homeless shelter, cutting the price of the Twitter Blue premium subscription service, plus giving the option to pay via the cryptocurrency Dogecoin. Also significant was a posting on 25 March, in which Musk presented a poll question. Free speech is essential to a functioning democracy. Do you believe Twitter rigorously adheres to this principle? Of the 2,035,924 votes that came back, 70.4% voted no. The next day, a follower asked Musk if he would consider developing a new social media platform himself, to which he replied, Am giving serious thought to this." Later, 4 April, he issued another poll. "Do you want an edit button?" referring to the ability to return to a tweet and edit it after it had been posted. 73.6% of more than 4.4 million voters replied yes. It feels clear that Musk wants to have a shaping influence over Twitter. Ironically, as the press quickly pointed out, not going on to the board of directors could actually give him better tools to wield this influence, as by rejecting the board seat, Musk would no longer be limited to a maximum 14.9% stake. He could potentially become the majority shareholder. Just days after I wrote the last sentence, Musk made a $43 billion offer to buy Twitter outright, saying that, "I think it's very important for there to be an inclusive area for free speech." Twitter subsequently accepted the acquisition, raised slightly to $44 billion. The situation is still very much playing out as this book goes to press, with Musk apparently withdrawing his bid for Twitter, although it remains to be seen whether this is the end of the story or is simply part of an evolving strategy. Time will therefore tell whether Musk eventually adds Twitter to his portfolio, but however it pans out, social media will certainly be a critical strand within Musk's commercial future. What is apparent is that in Twitter especially, Musk has found and mastered a uniquely pervasive platform for his views and announcements, and for his exceptionally effective strategies of indirect marketing. EV futures. A year after the Model S went on sale, Tesla finally made its first profit, with a quarterly revenue of $562 million, Vance 2015 271. But how times change. In 2021, Tesla's total revenue was $53.82 billion, which in itself was a 71% increase over the previous year. In October 2021, Tesla's market capitalization was valued at a stratospheric $1 trillion. The company now has 6 major factories around the world. In 2020 alone, Tesla manufactured 500,000 vehicles. Instead of customers going to classic car showrooms to view Teslas, they can simply buy them online and have them delivered to their door or collected from a delivery center. Tesla has an estimated 80% vertical integration, a degree of control over the production process virtually unheard of in automotive engineering. Early predictions that Musk was going to be destroyed by the big car makers have been quashed comprehensively. What's more, new vehicles are on their way, such as the strikingly angular and futuristic Cybertruck, pitched by Tesla as having better utility than a truck with more performance than a sports car, and the Tesla Semi, a full-scale lorry powered by 4 independent motors. One of Tesla's most revolutionary R&D engagements is its pursuit of self-driving technologies. In September 2014, it introduced the autopilot system capability on all its cars. This advanced assisted driving feature, delivered through powerful onboard software allied to multiple cameras and sensors around the vehicle, could take over certain driving functions from the human operator, such as parking, steering, and cruising within a driving lane, automatically accelerating or braking, and making optimal navigation decisions such as steering towards recommended highway interchanges. Autopilot features, according to the company's website, still require active driver supervision and do not make the vehicle autonomous. Yet Tesla is, at the time of writing, on the brink of delivering full self-driving FSD capability. The Tesla site clarifies that all new Tesla cars have the hardware needed in the future for full self-driving in almost all circumstances. The system is designed to be able to conduct short and long-distance trips with no action required by the person in the driver's seat. Tesla is not alone in pursuing autonomous driving technologies, nor is Musk naive about the challenge of achieving safe, competent FSD. The deaths of a small number of car drivers incurred while using autopilot mode have raised some questions about the relationship between driver responsibility and autonomous technologies. In Musk's interview with Lex Fridman, when asked about the problem of self-driving, he reflected after a pause. I thought that the self-driving problem wouldn't be hard, but it is harder than I thought. It's a lot of friggin' software, man. A lot of smart lines of code. For sure, in order to create an accurate vector space, you are coming from image space, which is this flow of photons going to the cameras. So you have this massive bit stream in image space, and you have to effectively compress a massive bit stream corresponding to photos that knocked off an electron in a camera sensor and turn that bit stream into vector space. By vector space, I mean like you've got cars and humans and lane lines and curves and traffic lights and that kind of thing. Once you have an accurate vector space, the control problem is similar to that of a video game, like Grand Theft Auto or Cyberpunk. If you have accurate vector space, having accurate vector space is very difficult. Many hurdles are to be crossed before we are being whisked between destinations in a car that drives itself, our lives and safety transferred into the digital hands of software and sensors. But given Musk's now undoubted ability to transform a technological feature, it is surely just a matter of time. The Tesla journey has not been plain sailing. As with all Musk's ventures, he has garnered controversy along the way. Tesla as a company faced accusations of sexual harassment from a small group of female employees in 2021, an accusation in which they implicated Musk's own behaviors and outlooks. There have been labor disputes over health and safety violations and concerns about financial reporting and anti-competitive practices. There have been accusations of racial discrimination at some of Tesla's plants. Musk's defiant views on COVID-19 stay-at-home orders also brought clashes with authorities and media. But however the world relates to Musk and Tesla, and however justified some accusations, both the company and its CEO keeps their eyes on the horizon, showing no signs of slowing down. In terms of the future, Musk's foot is not coming off the electric accelerator pedal. Chapter 5. The Full Picture. The accumulation of wealth and power has been likened to the flow of a river. The river by itself offers utility as it journeys to the sea, providing drinking and washing water to the communities that border the river, powering hydroelectric facilities, offering a transit route for boat traffic. But as the volume and flow rate of a river increases, more opportunities arise to tap off that water into separate distributaries. These minor streams or rivers then gain their own functions over a greater area. Crop irrigation is a good example. Thus, the distributaries begin with, and to a degree depend on, the main river, but over time they acquire an independent value all of their own. Applied to commercial expansion and the growth of wealth, the analogy is transparent. The more money is flowing through the river, the more opportunities there are to tap off some of that wealth into new own wealth-generating streams. It is essentially a visualization of the old adage, money begets money. Taking Elon Musk as a case study, we can clearly see how his commercial expansion deepened, quickened, and branched out over time. The capital generated from Zip2 beget X.com, and then PayPal. PayPal's eventual buyout provided the means to develop SpaceX and Tesla. Both of these companies have their own substrands, with SpaceX diversified from communication satellites to Mars missions, and Tesla from EVs to, as we shall see, solar panels and energy storage. In this chapter, we shall widen our focus to take in some of the other corners of Musk's entrepreneurial outreach, new flows of water that in themselves might turn into the rivers of the future. What is distinctive about Musk's commercial and intellectual empire, however, is the fundamental integration of all its elements into what truly matters to Musk. Musk is not a scattergun venture capitalist with a diverse portfolio of unrelated but profitable businesses. Instead, his enterprises form a fairly coherent jigsaw when looked at from a distance. Energy, space, transport, and computer-aided intelligence might seem like siloed ventures, but for Musk, they share the same mental space, while also opening up constant possibilities for interaction. Fundamentally, Musk's portfolio is about optimizing the human future through technology. Solar City and Tesla Energy. Elon Musk is a big believer in clean energy. We have seen this in Tesla's pursuit of the optimal EV and the constant investment in energy storage research, with ever more efficient generations of batteries. But to charge a battery, you need a power input in the first place. And in the modern age, that energy often comes from a power station burning fossil fuels. This does not mean that there is no net saving of energy in EVs. Power stations can produce energy with far greater efficiency than the sum of individual vehicles. But the next stage in the evolution of clean energy is to wean ourselves off fossil fuel power generation altogether. One avenue that Musk advocates is nuclear energy, the risks of which are greatly outweighed by the advantages it offers for clean and sustainable energy. Responding to fears of a Europe-wide gas shortage following the Russian invasion of Ukraine in February 2022, Musk tweeted on 6 March, "Hopefully it is now extremely obvious that Europe should restart dormant nuclear power stations and increase power output of existing ones. This is critical to national and international security." But another major strand of Musk's environmental thinking is solar power, which in his view greatly exceeds even the possibilities of nuclear. It's worth noting, I'm not sure if people are aware of this, but the world could be powered many times over by solar if you had enough battery capacity to pair with it. Many times, like 1,000, it's literally true. The amount of energy that reaches the Earth from the sun is staggeringly high. We have this enormous fusion generator in the sky that is lobbing out vast amounts of energy. And I'm talking about just using land area. I mean, it's really amazing. In fact, here's a little tip. If you take a nuclear plant and you take its current output and compared that to just taking solar panels and putting solar panels on the area used by the nuclear power plant, because these typically have a big keep-out zone, maybe 5 kilometers or thereabouts, where building houses of any kind of dense office or a housing space, usually people don't want to do that. So there's quite a big keep-out zone. And when you factor the keep-out zone into account, the solar panels put on that area will typically generate more power than the nuclear power plant. Musk's long-standing belief in solar energy has morphed into another of his major enterprises, which began its life back in a company called Solar City. Much like Tesla, Solar City first inches into existence in the hands of others, but with critical financial and intellectual involvement from Musk. In 2004, Musk made a suggestion to 2 of his cousins, the brothers Lyndon and Peter, that solar power presented a potentially lucrative and ethically worthwhile future opportunity. The Rive brothers had already run a successful data management company called Everdream and were receptive to a fresh ambition. Thus, on 4 July 2006, after a period of reflection and research, Peter and Lyndon Rive founded Solar City, with Musk as the company chairman and the biggest single investor, with about 30% equity in the business. The commercial model of Solar City ran as follows. The brothers would buy in solar panels, hence there were no manufacturing costs, install them, and provide the software, developed by themselves, for running the system. Here was the crucial part. The customer would pay no upfront costs for buying the panels, which in 2008 could be about $20,000 for an average house. Instead, they would lease the panels for a period of years, paying a fixed monthly rate. Financing was provided by Morgan Stanley via Solar City. Solar leasing became the dominant model for the U.S. domestic solar power industry in the USA, and Solar City was, initially, a resounding success. By 2013, it had become the leading solar residential installer in the USA and was also a major commercial supplier, providing solar installations for, among others, Walmart, Intel, and the U.S. military. The company had the scale to purchase several other big-time solar power companies and, by 2015, employed more than 15,000 people. By 2016, Solar City had provided solar installations for more than 325,000 customers. Musk had been interacting with Solar City from the outset and connecting it with his other lines of business. In a Tesla blog on 2 August 2006, Musk posted an intriguing document entitled The Secret Tesla Motors Master Plan, just between you and me. In it, he laid down at some length the energy arguments for his EVs, but near the end, there was a further section subheaded Becoming Energy Positive. The first paragraph linked out to SolarCity. I should mention that Tesla Motors will be co-marketing sustainable energy products from other companies along with the car. For example, among other choices, we will be offering a modestly sized and priced solar panel from SolarCity, a photovoltaics company where I am also the principal financier. The system can be installed on your roof in an out-of-the-way location because of its small size, or set up as a carport, and will generate about 50 miles per day of electricity. Solar panel installation would be just the beginning of the Tesla SolarCity synergy. In 2011, for a time it looked likely that SolarCity would be building electric charging stations for Tesla EVs in California, although this idea was replaced by Tesla's own brand charging stations the following year. In 2014, however, SolarCity began to sell powerful battery storage packs manufactured by Tesla to business and domestic customers. Tesla had itself, since 2012, been selling industrial battery storage units to industry, a growing commercial arena to be supported by the building of a new lithium-ion battery factory in Nevada, called Giga Nevada. This would open in 2016. In April 2013, Musk announced a new Tesla subsidiary, Tesla Energy, which would focus on the battery supply market, developing two major products, the Power Pack for industrial use and the new Powerwall for domestic use. Tesla Energy also launched the Tesla Megapack in 2019, a unit capable of storing 3 megawatts of electricity. Batteries, it should be mentioned, are a critical strand of Musk's environmental thinking, as banal as they might seem to us. Think well beyond the clip-in batteries we slot into our household devices. In September 2020, Musk spoke of humanity's need to push battery storage technology and solutions at a rate never before seen, giving homes and businesses the means to store energy derived from renewable sources like solar and wind, and use it during those moments when the supply drops, or sell it back to the grid. The rolling good times for SolarCity were interrupted brutally in 2015-16. Wider legislative and market changes in the U.S. solar industry hit profits. The company suffered reductions in new customers and reduced income streams, compelling it to make more than 3,000 employees, 20% of the company, redundant in 2016. But then, on 1 August 2016, Tesla made the announcement that it was buying SolarCity for $2.6 billion. SolarCity would now be absorbed into Tesla Energy, thus coming directly under the control of Tesla CEO Elon Musk. Lyndon and Peter Rive both left the company in 2017. Musk's acquisition of SolarCity made sense on several levels. Not only was it a company in which Musk had a founding role and that had commercial connections with Tesla, but it also offered a logical expansion of Musk's clean energy vision with the addition of solar power. Musk and his companies had also injected a great deal of money into SolarCity. In 2015, SpaceX purchased $165 million in bonds from the company, the only time to that date that SpaceX had ever invested in a publicly traded company. Higgins, 2021, 215. In a blog post dated 20 July 2016, Musk explained the merger. We can't do this well if Tesla and SolarCity are different companies, which is why we need to combine and break down the barriers inherent to being separate companies. That they are separate at all, despite similar origins and pursuit of the same overarching goal of sustainable energy, is largely an accident of history. Now that Tesla is ready to scale Powerwall and SolarCity is ready to provide highly differentiated solar, the time has come to bring them together. But the purchase of SolarCity has been one of the more controversial business decisions of Musk's career. Tesla's stock valuation almost immediately dropped $3.38 billion as investors were spooked by the acquisition of a company and an industry that were on the financial ropes. a group of major Tesla shareholders began legal proceedings against Musk and Tesla Inc., claiming that Solar City had major liquidity issues. Essentially, it was going broke, and that Musk knew that but did not share the information during the acquisition approval process. Musk was accused of securing the deal more for his own benefit than that of Tesla and its shareholders. The case is still in process in April 2022, at the time of writing this book. Musk has personally been in the spotlight and has vigorously defended the deal. On 18 January 2022, Reuters reported that during closing arguments, the aggrieved shareholders urged a judge on Tuesday to find Elon Musk coerced the company's board into a 2016 deal for Solar City and asked that the chief executive be ordered to pay the electric vehicle company one of the largest judgments ever of $13 billion. Howells, 2022. The case awaits its resolution. The move into solar power has brought other challenges for Elon Musk. These include Tesla being sued by Walmart in 2019 for fires caused by faulty solar panels fitted to the roofs of 7 of its stores. Walmart dropped the case in late 2019 after agreeing a settlement. The energy business was also tough. Reuters reported that in November 2019 that Tesla's solar panel market share has been falling, prompting the Palo Alto, California-based company to cut its sales force. Revenue from Tesla's energy generation and storage operations from January to September fell 7% from a year earlier to $1.1 billion. Stempel, 2019. There were also significant problems regarding Tesla Energy's development of a solar shingle, photovoltaic cells designed to look like and function as conventional roofing materials. Although the solar roof was demonstrated in 2016 on the set of Desperate Housewives, as it happened, it was subsequently revealed that the product was not working properly. By 2020, the product was still struggling to achieve production volumes. A Bloomberg article on 23 June 2021 carried the headline, "Tesla's solar rollout is a bust and a fixation for Elon." Hull, 2021. Tesla Energy might appear to be one of Musk's more struggling ventures, yet if history has proved one thing about Musk, it is that he has the tenacity to defy even the harshest of critics and eventually produce breakthrough results that confound almost everyone. Growth is once again appearing. In 2020, the company installed 205 megawatts, MW, of solar systems and 3,022 megawatts of electrical storage. But in 2021, those figures jumped significantly to 345 megawatts and 3,992 megawatts, respectively. Time will tell whether Tesla Energy's most influential days are yet to come. Going underground. On 17 December 2016, Elon Musk posted the following on Twitter. "Traffic is driving me nuts. I'm going to build a tunnel boring machine and just start digging." From anyone else, this would have been nothing but weary humor, but for a man with the vision and means of Musk, it signaled the beginning of a bold new venture. This time, instead of gazing into space or riding on the roads, Musk was looking to go underground, seeking another future of transportation beneath the Earth's surface. On 17 December 2017, he announced that he was forming The Boring Company, TBC. The humor in the name, the inspiration of Musk's then-wife Tallulah Riley, hinted at the initially casual, relatively speaking, nature of the project at first. But even though Musk would describe TBC as more of a personal hobby, accounting for 2 to 3% of his time, he still formed a team who attacked the project with gusto. In fact, even before the formation of TBC, Musk had a go at underground tunneling. The journalist Neil Strauss, writing for Rolling Stone magazine, stated that during one of his interview visits with Musk at SpaceX Hawthorne, California, he noted that employees were rushing around to move their cars from a staff car park. The reason, Musk had asked them how long it would take for them to relocate their vehicles to another parking location for the foreseeable future. Their answer, 2 weeks. Musk's reply, "Let's get started today and see what's the biggest hole we can dig between now and Sunday afternoon, running 24 hours a day." 3 hours later, the cars were gone, and Musk's engineering team started cracking the surface. Strauss, 2017. Soon, TBC was a major industrial venture in its own right, one that was plugged into the network of Musk's wider technological ambitions. Initially, the company was formed as part of SpaceX, but in 2018 it became a separate business, with Musk holding 90% of the equity, the remainder in the hands of key employees. Later, 6% of the equity also went to SpaceX. But what was the purpose of TBC? The overarching goals are captured by the company website, whose homepage declares, as of 19 April 2022, the Boring Company creates safe, fast-to-dig and low-cost transportation, utility and freight tunnels. The mission, solve traffic, enable rapid point-to-point transportation, and transform cities. It was clear that Musk was thinking big again, but as always, there was a logic at play. Musk has conceded that the development of EVs will do nothing to alleviate the global problem of urban traffic congestion. In fact, EVs could make it worse by ultimately developing a travel option that is cheaper than public transport. Elevated highways can only be built so high, and aerial vehicles are not realistic for mass transport. Tunnels, however, can be dug in great layers of highways through deep substrata. Musk has pointed out that the deepest coal mines are more than a mile deep, thus tunneling has a huge three-dimensional space to explore. If traffic is diverted into tunnels, then cities can become more beautiful, peaceful places. The tunnel traffic would, furthermore, be ordered but fast. Musk has mused on an upper figure of 241 kilometers per hour, 150 miles per hour. Autonomous driving technologies replacing stop-start queues with smooth, orderly, and congestion-free movement. Tunnel traffic would also be sheltered from external weather. There would be no noise pollution on the surface, and the multi-layer roads would not bisect neighborhoods and green spaces. Traffic and congestion will become a thing of the past, according to TBC. What Musk was not proposing, however, was that he develop a tunneling company just like any other. Instead, he is aiming to change the tunneling industry and its associated engineering with all the revolutionary spirit he has applied to other ventures. The first tunnel built by TBC was a 1.8-kilometer, 1.14-mile long R&D Hawthorne test tunnel, which ran out from the SpaceX property. The narrow, clean, and glowing tunnel space was unveiled to the press in December 2018. At the launch event, Musk explained more about his thinking on tunnels, including how to make their construction much cheaper and much faster. The present situation he outlined with reference to a slide presentation is that tunneling is slow, about 3 to 6 months per mile, which he pointed out was 14 times slower than the movement of a snail, and hugely expensive, at up to $1 billion per mile. TBC would do things differently. Major innovations would include 1. Smaller diameter tunnels. The tunnels will be built specifically for EVs, and the lack of exhaust gases and the absence of fume extraction systems mean that tunnels' diameters can be shrunk down, meaning less waste and quicker excavation. 2. Standardized diameters of tunnel boring machines, TBMs, to aid logistical efficiency. 3. TBMs that combine tunneling and reinforcement in a single process. Most TBMs have to stop frequently to allow other crews to install the reinforcements. 4. A TBM with 3 times the cutting power of typical industry machines. 5. Reuse of the extracted dirt. The dirt can be converted into bricks and sold, with the potential for brick sales to cover the cost of the tunneling. 6. Heavy automation of the tunneling process to improve efficiency and logistics. The innovations have borne fruit. The Hawthorne Tunnel was completed for less than $10 million. Then, in May 2019, TBC won a $48.7 million contract to build an underground loop system to take people around the expanded 200-acre Las Vegas Convention Center, LVCC. The LVCC Loop is a 3-station, 2.7-kilometer, 1.7-mile long installation of twin tunnels that links the LVCC West Hall with the existing campus. TBC Publicity explains that LVCC Loop opened in April 2021 for the Mecum motorcycle auction and has operated at all subsequent conventions. At SEMA 2021, LVCC Loop transported between 24,000 and 26,000 passengers per day. At CES 2022, LVCC Loop transported between 14,000 and 17,000 passengers per day, with an average ride time of less than 2 minutes and an average wait time of less than 15 seconds. The passengers are taken along the route by Tesla Model 3 and Model Y vehicles. However, TBC's plans for Las Vegas are far greater. The Resorts World LVCC connector will link Resorts World on the Las Vegas Strip directly to the LVCC. Phase 1 building work has already been completed at the time of writing. Construction is also currently underway for the even more ambitious Vegas Loop, a 47-kilometer, 29-mile-long tunnel network that will include LVCC Loop and any future service extensions, including those to casinos along the Strip. Harry Reid International Airport, Allegiant Stadium, downtown Las Vegas, and eventually to Los Angeles. Vegas Loop will provide fast and convenient transportation to the Las Vegas community, its visitors, and beyond. Where TBC will go remains to be seen. Certainly, the technological boundaries of tunneling are being tested by Musk's company. Its massive continuous mining Prufrock TBM, all the TBMs are named after poems or plays, is a supreme piece of TBC-developed equipment, able to start digging a 3.6-meter, 12-foot tunnel within 48 hours of arrival on site, going straight down from the surface to remove the need to dig expensive launch pits in advance. TBC states that the medium-term goal for Prufrock is to exceed 1/10 of human walking speed, which is 7 miles per day. The most ambitious TBC vision, though, is the Hyperloop, a regional long-haul transport system in which passengers are whisked around the country in autonomous electric pods at speeds of more than 966 kilometers per hour, 600 miles per hour, by means of magnetic propulsion in a special sealed low-pressure tunnel that reduces wind resistance. Development of a SpaceX Hyperloop test track began in 2015, and the track reached its full length by 2016. Not everyone, including many engineering critics, is convinced by TBC's claims and ambitions, but Musk has never proved to be an individual daunted by professional skepticism. Digital Horizons. Given Elon Musk's deeply techie background and interests, it would be easy to assume that all high-end advances in computer technology meet his approval. Yet his viewpoints are more nuanced than that, not least with regard to artificial intelligence. Musk has publicly stated a belief in the power and advantages of AI and an enthusiasm for its development, but is cautious when AI is married to robotics. With allusions to a Terminator-style robotic takeover, Musk has expressed fears that driving ahead blindly with AI-powered robotics would lead to machines with abilities far superior to our own, and which may eventually dominate us entirely, or worse. If AI had a goal, and humanity just happens to be in the way, it will destroy humanity as a matter of course, without even thinking about it. No hard feelings. It's just like if we are building a road and an anthill happens to be in the way. We don't hate ants, we're just building a road, and so, goodbye anthill. With more moderate language, he expressed similar sentiments in 2017 during a meeting of the National Governors Association, a Washington, D.C.-based nonpartisan political organization. Robots will be able to do everything better than us. I have exposure to the most cutting-edge AI, and I think people should be really concerned by it. Musk's concerns about AI have led him practically in two main directions. First, in December 2015, Musk and a group of other investors set up OpenAI, a research organization that, in its own mission statement, conducts fundamental long-term research toward the creation of safe AGI, artificial general intelligence. Together, the investors pledged $1 billion to the program, and although Musk resigned from the board in 2018, he continues to make financial contributions. OpenAI has a fascinating range of projects on its books, from advances in natural language AI, such as a computer creating an image purely from a textual description, to developing neural networks competent enough for a robotic hand to solve a Rubik's Cube. But returning to Musk's views on AI, what is perhaps the most interesting is how Musk sees the future integration between humans and AI at the level of biology itself. Given his concerns about where unrestricted AI might take us, surprisingly, his answer is not to retreat from AI, but rather to bring humans closer to it, in a more symbiotic and therefore controlling position with technology. In December 2015, he told the Seattle Times that, "What is the best thing we can do to ensure the future is good? We could sit on the sidelines, or we can encourage regulatory oversight, or we could participate with the right structure with people who care deeply about developing AI in a way that is safe and is beneficial to humanity." One of the main expressions of Musk's relationship to future-forward AI is Neuralink. Musk co-founded this neurotechnology company with a group of academic specialists in neuroscience, biology, and robotics in 2016, although it wasn't announced to the press until March the following year. Musk himself had reportedly put $100 million into the company by July 2019. The publicly stated aim of Neuralink is as follows. Neuralink is a team of exceptionally talented people. We are creating the future of brain interfaces, building devices now that will help people with paralysis and inventing new technologies that will expand our abilities, our community, and our world. The deep details of its work are largely secret, but Neuralink feels like it is delving into the pages of science fiction. Indeed, Neuralink's vision of neural lace, inserting profoundly fine probes into the brain to read, interpret, and act upon brain signals, has a conceptual link to the neural lace described in the fictional universe in The Culture, a series of sci-fi novels by Ian M. Banks. The immediate objective for Neuralink is the possibility of helping people with paralysis gain control of computers and electronic devices through brain power alone. Neuralink has already had success getting a monkey to play video games with its mind. But Neuralink acknowledges that the technology has the potential to treat a wide range of neurological disorders, to restore sensory and movement function, and eventually to expand how we interact with each other, with the world, and with ourselves. Where this could lead is profound or unnerving, depending on your position, and there have been many scientific critics of the Neuralink work. In an interview with Clubhouse in February 2021, Musk wandered into the realm of possibilities. The you of a month ago is not the same as the you of today. I mean, a bunch of brain cells have died, some memories have faded, some have strengthened. There are new memories. So, anyway, the point is, you wouldn't be. You could. There could be something analogous to a video game, like a saved game situation, where you are able to resume and upload your last state. Yeah, like in Altered Carbon, a sci-fi TV series in which consciousness is transferable. Maybe lose a few memories, but mostly be you, so now that's the long-term stuff. In the short-term stuff for Neuralink, the idea would really just be to address brain injuries or spinal injuries and make up for whatever lost capacity somebody has with a chip, an implanted chip. The idea of fundamentally integrating memory with technology is eye-widening, and it raises the greatest of ethical and existential questions. With companies like Neuralink, it seems like we are just cracking open a door that might lead into either sunlit vistas or dark alleys. Musk is attempting to ensure that it is the former. In a way, Neuralink offers the potential for humans to plug gaps in their intelligence, performance, and consciousness, possibly, one day, giving us all Musk-like minds. Getting educated. Musk's track record has, if anything, revealed a man who is intensely interested in intelligence, its formulation, expression, and practical output. While this interest has taken him into important areas of digital and artificial intelligence, it has also led to explorations of how intelligence is fostered socially, and that means addressing education. On the whole, Musk is deeply critical of the way that formal education, particularly in the USA, is currently structured and practiced. Education is an opportunity to give young people both a passion for learning and, equally, a range of intellectual tools and knowledge sets that will serve them well for the future. For Musk, most standard state and exclusive private education systems fail signally to achieve any of these goals. This failure extends all the way up to college level, with universities charging tens of thousands of dollars every year for an education that often gives the student little cognitive or employment advantage for the future. In typically direct fashion, Musk has attempted to tackle this problem by setting up his own education system. Before we delve into this school experiment, we can unpack Musk's views on education with more precision. In 2014 at South by Southwest, Musk was asked what he would do to change the education system. His answer clearly reflects his first principles strategy of thinking through a problem. Generally, you want education to be as close to a video game as possible, like a good video game. You do not need to tell your kids to play video games. They will play video games on autopilot all day. So if you can make it interactive and engaging, then you can make education far more compelling and far easier to do. So you really want to disconnect the whole grade level thing from the subjects, allow people to progress at the fastest pace that they can in each subject. It seems like a really obvious thing. Musk then went on to say that much schooling today has become little more than presentational, the teacher standing at the front and teaching the same content that they have been offering over several years. Elsewhere, Musk has also expounded a belief that the actual teaching content in schools is too divorced from practical, real-world problem-solving, a tendency that further disconnects the student from study, while also ensuring that the young adults that emerge are not always well-equipped to make an impact. Back at the South by Southwest event, Musk was then asked whether university was unnecessary. Given that many of his audience had likely spent or were in the process of spending tens of thousands of dollars on a college education, his answer cut to the quick. A university education is often unnecessary. That's not to say it's unnecessary for all people, but I think you probably learn about as much as you are going to learn there in your first 2 years, and most of it is from your classmates. Now, for a lot of companies, they do want to see the completion of the degree because they are looking for someone who will persevere through to the end, and that's actually what's important to them. But it really depends on what someone's goal is. If they want to start a company, then I would say there's no point in finishing college. It shouldn't be like there are these grades and people move in lockstep, and so everyone will normally go through English, math, science, and so forth, like 5th grade, 6th grade, 7th grade, like it's an assembly line. But people are not objects on an assembly line. It is relatively easy to see how Musk's personal history might inform his views on education, not least because most of the great leaps forward in Musk's life have been accomplished by doing things in a way that cut against the grain of conventional wisdom, and to a large degree conventional education. He has stated that when hiring his staff, he is more drawn towards the person who has dropped out of college to do something innovative and interesting rather than someone who has dutifully finished their program of study. He has also opined that high academic achievement offers no guarantees that it will translate into performance or achievement at work. In a summary sentence in another speech, Musk said that, "We need something new and exciting to latch onto. Something that will replace the severely outdated current education system." Musk's views on education began to find a low-key outlet in 2014, when he reportedly took his own 5 children out of their private education and started his own school, known as Ad Astra, Latin for "to the stars." Appropriately for its title, the school was founded within the SpaceX building in Hawthorne, California, as a kind of homeschooling project for Musk's children, and for those of a select group of SpaceX employees. This was a small group, There were only 9 pupils at first, and they were taught by one of the teachers from Musk's children's former school, the inspirational Joshua Don, plus one other teacher. The schooling was provided free and run on a not-for-profit basis, but Ad Astra was referred to as the most exclusive school in the world in an article in the Washington Post published in 2018. The article, and another published at the same time by Ars Technica, revealed just about as many details as were in the public domain. At the time, the only official information about the school was a LinkedIn page. The school had, by 2018, fewer than 50 pupils, aged between 7 and 14. According to an IRS Form 990 document, Musk himself was a substantial source of the school's funding. He contributed $475,000 to the school in 2014 and the same in 2015. The key difference in the way Ad Astra pursued education lay in its orientation to real-world problem-solving. Instead of rigorously dividing the teaching program into subject tracks, English, history, maths, etc., the students would be given complex, multi-layered problems to solve and would have to acquire the skills and knowledge to do so. These problems were generally linked to subjects close to Musk's heart and to what he sees as the properly relevant skills in the modern world. This led to some curriculum design decisions outsiders would find controversial. According to the Ars Technica article, the overriding focus is on science, maths, engineering, and, interestingly, ethics. Sports, music, and languages were not included, the latter all allegedly because Musk believes the computer-aided translation will eventually make the need for language learning redundant. Another module of curriculum focused on AI. Here is doubtless where ethics came into play, given Musk's views on the dangers of the technology. Apparently, the curriculum was, and is, revised every year in response to the previous year's experience and developments in the subject areas, with the students deciding about half of the content for themselves. But the innovations extended beyond curriculum, deep into classroom pedagogy. The statement on the school's initial LinkedIn page was, Ad Astra believes in promoting a love of learning, enduring curiosity, and unbounded imagination. Ad Astra is a laboratory school that embraces advancements in the fields of science, technology, and education. Ad Astra is dedicated to pushing each student to the frontier of his or her human potential. The phrase laboratory school here is crucial. Ad Astra's teaching focus was overwhelmingly project-based. Students tackled advanced technological challenges, especially within the A-frame module, which included constructing weather balloons and building fighting robots. Pupils were taught to code in Scheme, Scratch, and Swift computer languages, and many also took self-guided courses online. Numerous student-built websites proliferated. Notably, the school also created its own digital currency to aid the realism of internal trading projects. Each week, the student would have to complete an assignment called Folio, delving into a focused subject in depth. Ars Technica stated, one week it could be the cruise industry, the next, gentrification. In one exercise, students separated into 3 groups representing the USA, China, and North Korea, then had to engage in nuclear armament negotiations. Don told Ars Technica, one of the North Korean team members led the world to a nuclear holocaust, essentially. It was a truly impactful moment for that kid. Everything was hands-on or fully interactive. The fact that the school was located in an actual rocket factory made it the perfect environment to pursue this goal. Ars Technica described Ad Astra as fostering an atmosphere closer to a venture capital incubator than a traditional school. But it is clear that this is exactly what many parents in Silicon Valley wanted for their children. In 2017, again according to Ars Technica, 400 families competed for just 12 places in the school, admission being screened by the child taking a reasoning test developed by child psychologists. Yet the demand for Ad Astra clearly provided Musk and Don with food for further thought, not least how the principles of the school could be extended into the wider public domain, giving others beyond the SpaceX community access to the principles of real-world-centric education. The awareness of demand led in 2016 to the foundation of a new online school called Astronova, still led by Don, focused on students in the particularly formative age bracket of 6 to 14. The key difference between Ad Astra and Astronova was, according to Don himself, Ad Astra was the school at SpaceX that served 50 students. Astronova is the online school that aims to reach millions by sharing the insights from our work. Astronova's lean, super-modern website provides educational content that reflects its vision on adaptive critical thinking. The Conundrums section offers a variety of ethical and intellectual dilemmas, presented as video animations. The first of these, for example, is the Blue Comet Conundrum, in which pupils have to decide who gets to name a new blue comet spotted in the sky: a scientist, a student, or an astronaut, based on the backstory given to each individual in the presentation. The second major learning zone on the website is Synthesis, a collaborative problem-solving class that builds upon the practices established at Ad Astra. The promotional video for Synthesis demonstrates that, in a rapidly changing world, we believe that kids need to learn how to think for themselves. They need practice in solving complex problems through collaboration, and practice making tough decisions in the face of uncertainty. Through Astronova, students get to collaborate online with peers and facilitators from around the world. Kids compete in teams to solve complex problems that rework the tough decisions that we face in the real world. They build networks, curate art collections, manage ocean ecosystems, control wildfires, and colonize space. The key point of Synthesis is to get the students to practice making tough decisions with others, something the school sees as a factor distinguishing Astronova from most other education. Don has been the primary practical and pedagogical driving force behind both Ad Astra and Astronova. On the Astronova website, it states that the only directive from Elon was to make it great. The 2015 IRS filing showed that Musk spent only 1 hour a week at the school, unsurprising given his massive wider commitments. Yet it seems clear that the school's philosophy is a direct trickle-down from Musk's deeply held beliefs about how to make education relevant to a future that will be profoundly different at every level from the past. We only need to look at Astronova's 5 axioms of synthesis to see their relevance to how Musk has pursued his goals and tackled repeated challenges. 1. Embrace the chaos. 2. Test your assumptions. 3. Seek good explanations. 4. Expect course corrections. 5. Contribute to the good. Astronova is, of course, a drop in the ocean in the international education system. Nor is it entirely original. The principles of active learning and project-based real-world thinking have been discussed and developed for many years, with varying degrees of success and distribution. Given Musk's track record of disrupting conventional models and scaling up projects to have a global impact, Astronova and its principles may well come to have a far wider impact than we currently see. Chapter 6. The Musk Mindset. The world's self-made billionaires attract the interest of the general public for a variety of reasons: leadership and management skills, financial decision-making, investment portfolio, personal grit and tenacity. Although Elon Musk presents much to discover in each of these categories and many more besides, a substantial part of the public fascination comes down to an abiding interest in the way his mind works. The method by which Musk acquires and synthesizes knowledge is the subject of countless YouTube videos and articles, as the outside world attempts to deduce the secret formula of his prodigious intelligence. There lies the hope that as exceptional as Elon Musk is, There is something in there amounting to a transferable skill. Musk's exceptionalism in terms of intelligence is not just the veneration of lesser mortals looking in from the sidelines. Almost everyone who makes contact with Musk comes away from the encounter impressed by the dexterity and depth of his brainpower. For example, the American billionaire Charlie Munger, vice chairman of Warren Buffett's Berkshire Hathaway conglomerate holding company, a man noted not only for his sharp entrepreneurialism but also his management wisdom, was asked about his impression of Musk in a Q&A at the 2014 Daily Journal annual meeting. He replied, "I think Elon Musk is a genius, and I don't use that word lightly. I think he's also one of the boldest men that ever came down the pike." Munger's impression of Musk usefully captures the intellectual fuel that has powered the Musk empire, a fusion of acute brain power with innovative courage. It is clear that Elon Musk is not merely an entrepreneur. In many ways, the wealth outputs of his ventures are incidental, the necessary outcomes of intelligence applied to practical and engineering problems, rather than the goal of generating more money from existing money. Such effort belongs more to the realm of fund managers and venture capitalists. Musk is, fundamentally, an engineer. He has said, "I guess the way I usually describe myself is an engineer because most of what I do is engineering." That statement, as we will see, can be applied to almost every corner of Musk's business empire. Thinking it through. Although Musk has not written down his definitive formula for mental performance, he has given enough reflections upon thinking, education, intelligence, and problem-solving for us to get a reasonable insight into how he optimizes his mind. The good news, indeed, is that while Musk recognizes intelligence as partly a composite gift from genetics, nutrition, parenting, and other elements over which we have little or no control, there are certain rules of thinking that we can all acquire and apply. Simplifying, I see Musk's view of intelligence as grounded in the following. 1. The absorption and retention of information. 2. The synthesis of ideas and information. 3. First principles thinking. 4. Resistance to cognitive biases. 5. The conversion of ideas into action. Taking the first of these, there is no doubt that Musk is endowed with an exceptional memory, beyond that of even the most adept pub quiz team member. Although the validity of the concept of a photographic memory is one debated by psychologists, it does seem that from his earliest years, Musk was able to take a rapid imprint of data and information when they were presented to him. In discussions with Vance, Musk described his highly visual bias for mental processing as a young man, likening his brain to a graphics chip in a computer. Information, problems, and solutions came to him as accessible imagery, creating maps of meaning in his head. In 2020, during an interview at the Axel Spring Award, Musk responded to questions about his memory and whether it was truly photographic in nature. He responded, "I have a photographic memory in some respects. For technical stuff, I have a very good memory for a human. Computers are much better." The standout phrase in this quotation is, "very good memory for a human," as if Musk is both recognizing that he sits on the upper end of the intelligence scale, but at the same time is perfectly clear about the limitations of brain power in the human species. In a Reddit thread in 2015, Musk was asked by a knowledge-thirsty follower, "How do you learn so much so fast?" Before giving the answer, to which we shall turn in a moment, Musk was open about the fact that he was not claiming intellectual Superman status. "I do kind of feel like my head is full. My context switching penalty is high and my process isolation is not what it used to be." Musk here self-analyzes using the language of computers. By treating his own brain as a physical system, a product of natural engineering with certain performance and structural characteristics, Musk seems to probe the possibility of compensating for system problems through mental engineering improvements, or ultimately outsourcing intelligence to more robust systems in the digital domain, as we saw in the previous chapter. In the rest of the Reddit entry quoted on the previous page, Musk does offer a practical insight into how he organizes and retains information in his head, and makes some encouraging noises for the regular public. Frankly, though, I think most people can learn a lot more than they think they can. They sell themselves short without trying. One bit of advice: it is important to view knowledge as sort of a semantic tree. Make sure you understand the fundamental principles, i.e. the trunk and big branches, before you get into the leaves, details, or there is nothing for them to hang on to. Musk's semantic tree has been pored over by business analysts and thinking experts. It is grounded in solid psychological theory and practice. Memories are generated by three fundamental processes. 1. Attention. An active concentration directed towards the inputs that need to be remembered. 2. Encoding, storing the information in such a way that it moves from the short-term memory to the long-term memory, especially through associating the new inputs with existing knowledge and memories. 3. Retrieval, bringing the memories back into consciousness. Musk's idea of the semantic tree powerfully addresses all three elements of memory formation, in a way that is practical and quick to apply. The semantic tree is essentially a way of organizing information mentally. The trunk of the tree is the core topic being studied, and the subsequent fork and the very largest lower branches are the key subdivisions of that topic. You have to understand all these, simply and sturdily, before anything else can be added. It is pointless spending your thinking time attempting to remember hundreds or thousands of disconnected chunks of information as they flit through your consciousness, as they are not integrated into the network of associations. With the trunk, fork, and major boughs secured, in both detail and concept, the thinker can then more successfully add the detailed information of the finer branches and twigs. Formulating knowledge using this framework, either instinctively or as a deliberate memory device, reinforces the process of both attention and encoding, as the brain actively places all the pieces of information in an associative context, every individual byte of information reinforced by the rest. But the framework also assists retrieval, as the thinker can follow the paths from the trunk upwards, each connection acting as a prompt for recall by association. Using such a system, the whole memory structure then has strong roots. Of course, Musk may well be speaking of the semantic tree as an analogy rather than a deliberate memory device, but this in no way impairs the effectiveness of principle. Musk is encouraging us to get to grips with fundamental ideas first, then hang the details off this secure framework. Synthesis. The second part of a putative Musk mindset, the synthesis of ideas and information, refers to the way Musk seems to bring in thinking from many different realms to solve problems with innovation and disruption. And here, he has a long-standing but simple advantage. Musk reads a lot, and the right sort of works. The leaders are readers principle has a long and respected back history, and Musk embodies it perfectly. In his childhood, recounted in Chapter 1, Musk voraciously consumed entire shelves of books as if draining them of information. To this day, Musk has maintained the activity of reading informative, interesting, and challenging books. Although he reads a wide range of content, his patterns of reading do not seem to be purposeless intellectual wandering. Rather, they are a directed effort to give his semantic tree more associative branches, which in turn gives him more base material with which to make informed decisions and connected innovations. Musk has revealed an ever-evolving short list of the titles that have been particularly important to his thinking, or which he has publicly recommended. A selection of these titles includes 1. The science fiction works of Isaac Asimov and Robert Heinlein. 2. J.R.R. Tolkien, Lord of the Rings, 1954-55. 3. Frank Herbert, Dune, 1965. 4. Ayn Rand, Atlas Shrugged, 1996. 5. J.E. Gordon, Structures, or Why Things Don't Fall Down, 2003. 6. Nick Bostrom, Superintelligence, Paths, Dangers, Strategies, 2014. 7. Max Tegmark, Life 3.0, Being Human in the Age of Artificial Intelligence, 2017. 8. Ian Goodfellow, Joshua Bengio, and Aaron Corville, Deep Learning, 2016. 9. Naomi Oreskes and Eric M. Conway, Merchants of Doubt, How a Handful of Scientists Obscured the Truth on Issues from Tobacco Smoke to Climate Change, 2010. 10. Sean Carroll, The Big Picture, On the Origins of Life, Meaning, and the Universe Itself, 2017. 11. Sam Harris, Lying, 2013. 12. Adam Smith, The Wealth of Nations, 1776. 13. Walter Isaacson, Benjamin Franklin, An American Life, 2004. And Einstein, His Life and Universe, 2008. 14. Donald L. Bartlett and James B. Steele, Howard Hughes, His Life and Madness, 2004. 15. Robert K. Massey, Catherine the Great, Portrait of a Woman, 2011. 16. Richard Branson, Screw Business as Usual, Turning Capitalism into a Force for Good, 2017. 17. Peter Thiel, 0 to 1, Notes on Startups or How to Build the Future, 2014. This list is just the thinnest of slices from hundreds of works that Musk has read over his lifetime, but it gives a measure of insight into the types of information and thinking to which he gravitates. They break down into certain logical categories. Science fiction and fantasy novels are common on the shelves of tech entrepreneurs, being genres with an obvious attraction for those fascinated by futurity. But Musk ranges more widely and freely across the non-fiction spectrum, from philosophy and science across to biographies and business management. While this might, at first glance, appear to be an indicator of a flitting mind, seen holistically, Musk's reading habits are far more to do with intellectual syncretism, merging different fields of study into a unified whole, each topic feeding into the other. Some titles from Musk's reading list certainly come across as more central to his life experience than others. In an interview with Alison Van Diggelen on 22 January 2013 at the Computer History Museum, for example, he explained how one title in particular, read while he was still a boy, opened up some critical philosophical and logical vistas for him. I guess when I was around 12 or 15, I had an existential crisis, and I was reading various books on trying to figure out the meaning of life and what does it all mean. It all seemed quite meaningless, and then we happened to have some books by Nietzsche and Schopenhauer in the house, which you should not read at age 14. Laughter. It is bad. It's really negative. So then I read Hitchhiker's Guide to the Galaxy, which is quite positive, I think, and it highlighted an important point, which is that a lot of times the question is harder than the answer. And if you can properly phrase the question, then the answer is the easy part. So, to the degree that we can better understand the universe, then we can better know what questions to ask. Then whatever the question is that most approximates what's the meaning of life, that's the question we can ultimately get closer to understanding. And so I thought to the degree that we can expand the scope and scale of consciousness and knowledge, then that would be a good thing. Musk is far from the first tech entrepreneur to be influenced by the Hitchhiker's Guide to the Galaxy. The point he makes about the importance of questions, however, still seems relevant to his way of thinking. The questions we ask, and particularly the clarity with which we frame them, are engines for generating ideas and forward momentum. For Musk, ideas on the page are not frozen there. He takes written concepts, facts, beliefs, data, and more, and then activates them in reality, something also proven to be cement information firmly in the memory. His reading is, above all, pragmatic. We can see this in some very direct instances. For example, at the conceptual stages of SpaceX, Jim Cantrell lent Musk several key textbooks, including Rocket Propulsion Elements, 2010, Aerothermodynamics of Gas Turbine and Rocket Propulsion, 1996, Fundamentals of Astrodynamics, 1971, and the International Reference Guide to Space Launch Systems, 2004. Cantrell has publicly stated his amazement at the way Musk committed the information from these titles to memory, being able to recount lengthy passages verbatim. So, Musk literally taught himself rocket science. But Cantrell has also explained that Musk does not overestimate his capabilities for mastering any given subject, regardless of his formidable powers of knowledge acquisition. He notes that Musk is equally attentive to expert people, spending time with or hiring the best representatives in relevant fields. Cantrell observed that when Musk was in the company of experts, he would give them his fullest attention. It was as if he would suck the experience out of them. He truly listens to people. Musk's ability to direct absolute attention to what he is studying or the people he is talking to is imperative to understanding his accelerated learning. Strong attention anchors the first two elements of memory formation, encoding and storage, and thereby lays firm foundations for the final retrieval stage. For Musk, the semantic tree is strengthened by the way its branches are united in a purposeful trunk. Reflecting on his reading of Isaacson's biography of Benjamin Franklin, Musk mused, in an interview for CNN, that, "I think in the case of Franklin, he did what needed to be done at the time it needed to be done. So he was in different fields, and he thought about what was the most important thing that needed to be accomplished right now, and he worked on that." Like Musk, Franklin was a true polymath. He was a writer, printer, and publisher, a political philosopher, a scientist and inventor, a statesman and diplomat, one of the founding fathers of the USA, most famously a drafter and signer of the Declaration of Independence, the first U.S. Postmaster General, the first U.S. Ambassador to France, and President of the state of Pennsylvania. But Musk recognizes that there is a world of difference between knowing something and getting something done with that knowledge. To make that transition, the mental library of knowledge and skills needs directing into a purposeful and focused endeavor. Musk is a disruptor by nature. On a Quora post, Cantrell was asked the provocative question, "Is Elon Musk a visionary or just a crazy man?" The opening to his response stepped outside the interrogative framework. "He's actually neither, in my opinion. He's a rogue. He has some very grandiose visions, make mankind a multiplanetary species and to remove humanity's dependence on fossil fuels, to which he applies enormous energy, time, and resources. Elon is very intelligent, has a nearly inexhaustible energy, and possesses an incredible appetite for making progress. He is really a rogue because he does it outside of the normal channels of thinking and outside of the normal channels of doing. He, like many of us who have joined him at various parts of his adventures, simply realized at a point in our lives that radical transformation cannot happen within the system, but must happen from outside the system. Some of us even believe that the larger economic system and society actually hinders progress, and you have to be on the outside of it to truly change things for the better." Here, Cantrell persuasively makes his case for the rogue interpretation of Musk's character. What could appear to be the vaunting ambitions of a man unchained from reality are in reality the hyper-pragmatic ambitions of a man defying conventional thinking and attempting radical transformation. This angle on life is surely also a key ingredient in Musk's mental ability. Memory and innovation are both strengthened by stepping outside standard models, an act that reinforces the ownership of thinking rather than simply wearing a deeper groove in well-worn paths. First principles. This leads us to another cornerstone of Musk's mental gymnastics, what he calls reasoning from first principles. Here, Musk encourages us to free ourselves from conformity, to simply reworking existing trends of thought, and instead go back to understanding the groundwork on which the whole discussion rests, and then innovating and problem-solving from that basis. It is again, in many ways, a reflection of the semantic tree theory, the thinker laying the roots and growing a robust trunk of understanding before adding the sophisticated superstructure of boughs and branches. What is important, however, is that the thinker ditches much of the baggage of existing knowledge before thinking the issue through. Musk explained thinking via first principles in an interview with Kevin Rose for Innovator. I think it is also important to reason from first principles rather than by analogy. The normal way we conduct our lives is that we reason by analogy. We're doing this because it is like something else that is being done, or it's like what other people are doing. It's like iterations on a theme. It's mentally easier to reason by analogy than by first principles. First principles is kind of a physics principle of looking at the world, and what it means is that you boil things down to the most fundamental truths. We say, what are we sure is true, or as sure as possible is true, and then we reason up from there. And that takes a lot more mental energy. What is perhaps most interesting in this passage is the summary statement about first principles thinking requiring less mental energy than reasoning by analogy. He does not specifically explain why it should be less mentally taxing, but I might suggest that it frees that mind from constantly wrestling to struggling to integrate the knowledge and information of others. There is also the possibility that reasoning by first principles is more motivating and exciting, which in turn produces more mental stamina. In an important interview with Lex Fridman in December 2021, Musk went deeper into first principles thinking. He connected it explicitly with physics, stating that physics is law and every other thing is suggestion. Anyone can break the law, but no one can break physics. He grounded this statement by explaining that first principles thinking can be applied to all manner of life problems, not just scientific ones, but the crucial point was that you define the fundamental realities of the situation, the things that we are most confident are true, and then sit subsequent thinking atop this platform, setting your axiomatic base. Any conclusions derived thereafter have to be cross-checked against the foundations that have been established. In his aforementioned interview with Kevin Rose, Musk gives an example to demonstrate this approach to critical thinking. He looks specifically at battery technology. In his view, the conventional thinking about battery packs is that they are, of necessity, both heavy and expensive, costing about $600 per kilowatt-hour of energy. Because that's how batteries have been in the past, that's how they will be in the future. Musk calls this thinking pretty dumb, and argues that this line of reasoning will never result in turning the wheel in a new direction. Instead, he advocates going back to first principles with a set of simple but directed questions. What are the material constituents of the batteries? What is the spot market value of the constituents? So you can say it's got cobalt, nickel, aluminum, carbon, and some polymers for separation and a steel can. So break that down on a material basis and say, okay, if we bought that on a metal exchange, what would each of those things cost? It's like, it's like $80 per kilowatt hour. So clearly, you just need to think of clever ways to take those materials and combine them into the shape of a battery cell, and you can have batteries that are much, much cheaper than anyone realized. Going back to the Fridman interview, we see Musk add another nuance to his strategy for breaking problems down into fundamental concepts. He explained how another good physics tool is thinking of things in the limit. In this methodology, Musk talks about seeing how the problem shifts in nature when you scale it up to a very small number or a very large number. In manufacturing, for example, the cost models change radically depending on whether you are producing single-digits units or whether you are producing millions of units. Scaling in either direction can reveal what needs to be done to reach the requisite efficiencies of time and cost. Cognitive biases. By all accounts of former employees, being under the hot lamp of Elon Musk's questioning can be a deeply uncomfortable experience. On any matter, be it an engineering challenge or a point of financial management, Musk will ruthlessly squirrel into the heart of the issue through relentless and close questioning, until he feels satisfied that he has reached either clarity or a solution. Woolly or imprecise thinking can generate a heated response, particularly in relation to issues that are fundamental to the efficiency and realization of the project vision. Musk's interrogations apparently take little account of the personal feelings of those facing the logical barrage. All that matters is the answer. Ryan Popple, an ex-U.S. Army man appointed as Tesla's director of finance, explained of Musk's presence in the company during the tumultuous times of the late 2000s. "If you started falling behind, there was hell to pay. Everyone could see it, and people lost their jobs when they didn't deliver. Elon has a mind that's a bit like a calculator. If you put a number on the projector that does not make sense, he will spot it. He doesn't miss details." Quoted in Vance, 2015, 182. Employees have also noted, however, that if under interrogation, the responder holds up their side of the equation and provides relevant details and new information that have merit, then Musk might indeed change his mind and direction. What matters to Musk is the answer, not the ego. He has said that it is actually vital to elicit critical feedback, particularly from friends, as the latter will hopefully combine honesty with having your best interests at heart. A context for Musk's unwavering commitment to extracting the best thinking from his employees is a tweet he posted on 19 December 2021. Simply, "Should be taught to all at a young age." He followed this statement with a graphic produced by TitleMax, headed 50 Cognitive Biases to be Aware of so you can be the very best version of you. The graphic lists, with short examples of each, 50 fundamental errors in thinking. They included elements such as self-serving bias, in which we take credit for our successes but not for our failures; curse of knowledge, where we assume that everyone knows what we do; Google effect, aka digital amnesia, we quickly forget information that we look up online; authority bias, in which we are unduly influenced by authority figures without testing their theories; and blind spot bias, where we think bias is only for other people and not for ourselves. The full list, a link is provided in the bibliography, is well worth the study time, as it exposes the mind's deep internal wrestle between truth and error, with many ingrained tendencies trying to steer us towards the latter. During his interview with Lex Fridman, Musk gave a more scientifically nuanced view of the operating system running inside our minds. We currently operate on two layers. We have a limbic, like primitive brain layer, which is where all of our impulses come from. We've got like a monkey brain with a computer stuck on it. That's the human brain. And a lot of our impulses and everything are driven by the monkey brain. And the computer of the cortex is constantly trying to make the monkey brain happy. It's not the cortex that's steering the monkey brain. It's the monkey brain steering the cortex. Surely the really smart thing should control the dumb thing, but actually the dumb thing controls the smart thing. The conversation went on to Musk reflecting on developing a tertiary layer of intelligence, the digital superintelligence discussed in the previous chapter. Sticking with biological potentiality, however, it is clear that Musk does not see human beings as operating purely within the tidy boundaries of reason. The natural human tendency is for wishful thinking, he has stated. While Musk would never claim to have freed himself from either cognitive biases or the limbic system, he has repeatedly demonstrated a pattern of mental nonconformity. He has said in interview how his study of physics in particular has been useful in sharpening his thinking, as it teaches the students to go back to the first principles outlined above and follow the scientific framework rigorously until the thinker gets as close to truth as possible. The framework even holds good when thinking about the most counterintuitive elements of physics. Musk references quantum mechanics as an example. The method, by its nature, providing a counterbalance to the cognitive biases you might automatically bring to such problems. Musk has also advocated a general investment in good critical thinking processes. Just in general, critical thinking is good, examining whether you have the correct axioms or the most applicable axioms. Does the logic necessarily connect? And then, what are the range of probable outcomes? Outcomes are usually not deterministic, but they are a range. And so you want to figure out what those probabilities are, to make sure, ideally, that you are the house. It's fine to gamble as long as you are the house. This last statement is a pithy frame to put around much of Musk's career, which has typically involved gambling to an extent that would induce a heart attack in most of us. The logical method, in essence, is the house, the computer of the cortex, a locus of control that can reduce, never remove, the risk from the roulette wheel, while also protecting the self from the primitive drives and impulses that might cause us to act in ways that are not in our best interests. Musk also seems to apply his models of critical thinking to the hiring process. As we have seen throughout this book, Musk and his companies gravitate towards super bright people with slightly maverick tendencies. They also prize individuals who have the practicality and youthful energy to get things done, without the lazy warmth that can be generated by a big corporate structure, accustomed to more stratified and documented working methods. One element Musk lasers in on during recruitment and interviewing is demonstrable proof that the individual is capable of A. solving problems with creativity and innovation, and B. can get things done. On 6 November 2020, Musk tweeted to his Musketeers, "When sending your resume, please describe a few of the hardest problems you solved and exactly how you solved them." The request in some ways appears simple, but it has hidden sophistications. It bypasses the focus on qualifications to reframe thinking on process and achievement. It also cuts through the self-laudatory padding that often gathers on CVs. To Musk, it doesn't matter what you feel about yourself, it only matters how you think and what you can do. Be rigorous in your self-analysis is another pertinent Muskian piece of wisdom. The bias for action. Of course, the world is replete with academically intelligent people who have never achieved even a fraction of 1% of what Elon Musk has in his 5+ decades on this planet. In one interview, Musk was asked directly what it is that separates him from other brilliant engineers or very capable managers, in terms of the immense qualitative and quantitative difference in achievements. The question brought something of an awkward and hesitant moment of reflection on Musk's part, almost as if the question wasn't really relevant to the way he sees the world. But when an answer haltingly emerged, it was revelatory, with a touch of humor and realism. First of all, I certainly don't think that I can do anything or that I can do most things that people think are impossible. A lot of what people think is impossible is actually impossible. But occasionally, it's not. Really believe in what you are doing, but not just from a blind faith standpoint, but to have really thought about it and said, okay, this is true, I'm convinced it's true, I've tried every angle to figure out if it's untrue, and sought negative feedback to figure out maybe if I'm wrong. But after all that, it still seems like this is the right way to go. I think that gives one a fundamental conviction and an ability to convey that conviction to others. Musk's opening lines here push back against the "believe you can achieve the impossible" mantras that characterize the more optimistic strands of Western business self-help. Musk believes that humanity has a natural leaning towards wishful thinking, and just the act of believing you can do something does not always make reality conform. What is far more powerful, Musk here outlines, is to have a truly compelling idea that motivates you at every level, including cognitively. It is this intellectual part that is often missing from many motivational addresses. Musk finds motivation in a good idea after it has been rigorously tested and analyzed and still seems to hold its potential and value following pressure testing. Of course, this does not remove risk, a factor to which Musk has confessed he has a high tolerance, but in many ways his achievements are precisely matched with his logically considered ideas. Seen through this lens, Musk's legendary capacity for working superhuman hours becomes perhaps a little more understandable. The idea provides its own energy and drive. After that, things get a bit more basic. Be extremely tenacious, and then just work like hell. I mean, you have to put in 80 to 100-hour weeks every week. Musk certainly has, in unbeatable volumes, what we might term grit. Vance quotes Antonio Gracias, the founder and CEO of Valor Equity, who witnessed Musk at the full peak of stress management in 2008. Gracias explained that in his view, the experience Musk went through in 2008 would have broken anyone else. Yet he witnessed Musk digging into impressive reserves of focus, attaining a hyper-rational state that gave him exceptional powers of long-term decision-making, even when under continual and exhausting pressures. In Gracias's view, this quality is one characteristic that truly separates Musk from many other executives within his company and many other competitors without. He can withstand levels of intellectual pain and mental discomfort that few others can, with Gracias noting that Musk's cognitive ability seems to increase in power in inverse proportion to the pressures placed upon him. The harder it gets, the better he gets. Vance 2015, 214. Such a quality is a rarity in any field of endeavor. Perhaps the only hint of why Musk is able to achieve this is the reference to his becoming hyper-rational. It is certainly the case that the greatest enemy of a successful outcome to a stressful situation is panic. Musk maybe simply gets that fact and realizes logic and application offer the best exits. The idea that long working hours equates to productivity has been questioned over recent years by leading economists and academics specializing in workplace practices. For example, a productivity study by Stanford and Institute for the Study of Labor, IZA, economics professor John Penseville in 2014 found that productivity per hour dipped significantly after 50 hours per week. And after 55 hours, the productivity drops off so much that any extra hours contribute almost nothing to the weekly output, although this study was focused on manual workers. Similarly, a study of consultants by Aaron Reed, a professor at Boston University's Questrom School of Business, discovered that by and large, senior management could not distinguish the productivity outputs between those consultants who worked 80 hours per week and those who merely pretended to do so. In the case of Musk, however, he does appear to have an elevated capacity to push himself to work longer hours with genuine productivity. He has proven this not just in nebulous management challenges, the type that offer frequent opportunities to burn away time without overly intensive work, but in hardened engineering work, such as writing software code through the night, or working several days straight on the workshop floor at SpaceX to get a job done. Musk has certainly seemed at times less than sympathetic towards those who aspire to more balance between work life and home life. One Tesla employee, for example, told Vance that Musk berated him for taking time off to be present at the birth of his child. Allegedly, Musk said in an email, "We're changing the world and changing history, and you either commit or you don't." Vance 2015, 182. Vance acknowledges in a footnote that he did not see the email personally. The combination of a superb functional intelligence, high motivation behind a proven idea, an elevated tolerance of risk, and the ability to work with Herculean endurance are key characteristics behind Musk's success. There have been recent signs that Musk might be conceding some ground to the effects of age, however. In August 2018, Musk gave an interview to the New York Times in which he appeared to confess some of the symptoms of corporate burnout. He reflected upon the fact that he hadn't taken more than a week off work since 2001, that recently he had been doing 120-hour weeks. On occasions, he would spend 3 or 4 days within his factory facilities without leaving or going outside, and that on the night of his 47th birthday, he worked for 24 hours straight, and that his sleeping was affected, requiring him to take Ambien, sleep medication. The Tesla stock price fell by as much as 8% on the day following publication of the interview. While some might say that Musk's admissions were signs that he is slowing down, I would argue that the implications are rather different. Musk, to my knowledge, while accepting he has certain heightened abilities, has never claimed that he is any sort of superhuman. Indeed, Musk is perfectly aware of the flaws in the system of every human being. What ultimately matters to Musk is following the logic, however it presents itself. Conclusion. Elon Musk is a figure of controversy. Of that, there is no doubt. Slip a bookmark into almost any chapter of his life, and there will be some personal Musk story or incident that absorbed as many column inches as his business exploits. His intimate life has been under particularly microscopic evaluation. His marriage to Tallulah Riley ended in divorce in 2012, then remarriage in 2013, then a final divorce in 2016. He subsequently dated the Hollywood actress Amber Heard in 2017. This relationship became entwined in the media through Heard's subsequent and disastrous marriage to the actor Johnny Depp, the latter in court proceedings accusing Heard and Musk of having an affair during the marriage, an accusation Heard flatly denied. In 2018, Musk began dating the Canadian musician Grimes, and they bore a son in May 2020 named XAA12, or XAI. Pronunciation according to interviews with Musk and Grimes. They also have a daughter, Exa Dark Sidereal Musk, born in December 2021 via a surrogate. The couple subsequently and amicably separated. At the time of writing, there have also been press reports that in 2021 Musk fathered twins with Siobhan Zillis, an executive from Neuralink. The media's magnetism towards the personal relationships of celebrity is long-standing. Musk has provided them with other ingredients for consumption. In classical terminology, we might view him as an eccentric. He has appeared in minor parts on screen, such as the films Iron Man 2, 2010, Why Him, 2016, and Men in Black International, 2019, and several TV series, including The Simpsons, The Big Bang Theory, South Park, and with more gravitas, in the Netflix documentary Return to Space. Musk even hosted the Mother's Day 2021 episode of Saturday Night Live, SNL, in which his mother also made an appearance. Her most memorable line, "I'm excited for my Mother's Day gift. I just hope it's not Dogecoin." For good measure, Musk has written and released and partly performed 2 music tracks, one a rap, R.I.P. Harambe, and the other, for the electronic dance music EDM genre, Don't Doubt Your Vibe. In December 2019, a new severe respiratory virus was detected in the city of Wuhan, Hubei province, China. By the spring of 2020, what we now know as COVID-19 has spread globally, beginning a pandemic that plunged the world into the worst social crisis since the Second World War. Entire nations were plunged into law-enforced lockdowns of varying severity. Hospitals creaked and failed under the avalanche of COVID cases. Pharmaceutical companies raced and succeeded to develop new vaccines with unheard-of acceleration. Culturally, there was violent debate over the right way to handle the disease, and indeed disagreement as to what level of threat it presented, and whether chosen responses were proportionate or not. In September 2020, Elon Musk appeared on the Joe Rogan podcast. The meeting of the two men naturally generated high expectations, not least because of Rogan's undoubted talent in getting his guests to relax and express views over the prolonged discussion that they might not otherwise voice. The interview certainly didn't disappoint, and is recommended viewing/listening for those who want an enjoyable unfolding and at times intimate insight into Musk's personality and his views on life and work. It also brought the moment when Musk took a single drag on a cigar, which Rogan claimed was laced with cannabis, an act that appeared to drop the price of Tesla stock by a few points the next day. Musk flatly denied he was a pot smoker in a subsequent 60 Minutes interview. One interesting moment came when Rogan asked Musk about his opinions on the COVID-19 lockdown policies. The pandemic was raging at its height at this time. He questioned Musk about whether he agreed with those who argued that people should be allowed to go back out and work or whether the continued lockdown should be enforced. Musk's reply forms a useful initial step for moving this biography towards a close. My opinion is that if someone wants to stay at home, they should stay at home, and if someone doesn't want to stay at home, they should not be compelled to stay at home. That's my opinion. This notion, though, that you can just sort of send checks out to everybody and it will be fine is not true, obviously. Some people have this absurd view that the economy is like some magic horn of plenty, like it just makes stuff. There's a magic horn of plenty and the goods and services just come from this magic horn of plenty, and then if somebody has more stuff than somebody else says, they just took more from this magic horn of plenty. Now, let me just break it to the fools out there. If you don't make stuff, there is no stuff. We've become detached from reality. You can't just legislate money and solve these things. If you don't make stuff, there is no stuff. We can extract 2 points from this dialogue, connected but also standalone. The first is that Musk's views on the lockdown added fuel to an already roaring fire. Musk was already deep in disputation over his stance on COVID-19. On 13 March 2021, for example, Forbes magazine published an article with a loaded title, Elon Musk's False COVID Predictions, a Timeline. Among the examples given were a tweet, 6 March 2020, in which Musk stated that the coronavirus panic is dumb. Another in which he predicted 0 new cases by the end of April 2020. An announcement, 11 May 2020, that Tesla is restarting production today against Alameda County rules. I will be on the line with everyone else. If anyone is arrested, I ask that it only be me, and raising some questions about the safety of vaccines. This author will not plunge into the deep and turbulent waters of the rights and wrongs of Musk's COVID-19 viewpoints. From his interview, however, we can perhaps sense why Musk might instinctively resist the lockdowns and public reactions. Quite simply, we have to make stuff. Musk is essentially a realist, and no amount of wishful thinking can get away from the hard facts of production and consumption, and how necessary they are for a society to thrive and grow. Looking across Musk's portfolio, he is very much about stuff. Spaceships, cars, boring machines, batteries. He also has a high risk threshold. In April 2021, he tweeted, "To be clear, I do support vaccines in general, and COVID vaccines specifically. The science is unequivocal." But he widened the discussion in the Time Person of the Year article in December 2021 when he gave his thoughts about those who chose to go unvaccinated. "You are taking a risk, but people do risky things all the time. I believe we've got to watch out for the erosion of freedom in America." For Musk, the social and political freedom to pursue one's goals is paramount in a healthy society, and he is cautious about the potentially widening justifications for curtailing freedoms. Perhaps the greatest of Musk's controversies came in July and August 2018, when he was in a spat with Vernon Unsworth, a British diver living in Thailand who assisted in the globally publicized rescue of 12 boys from the water-filled Tam Luang Nang Non cave in Chiang Rai province, northern Thailand. Unsworth criticized the responsive efforts of Musk and the Boring Company to develop a mini-rescue submarine, saying it was just a publicity stunt, and that counter-accusations began. Most damaging was Musk's taunt that Unsworth was a pedo guy, and following this, "You don't think it's strange he hasn't sued me?" The affair escalated into Unsworth launching a defamation case against Musk in December 2019, seeking $190 million in damages. Musk apologized, but was also found not liable for damages, having explained that some of his taunts were just boilerplate hard language from his childhood in South Africa. Taken together, the controversies surrounding Musk can be a deal-breaker for some people. But I go back to our introduction and Time's defense of Musk as Person of the Year. Whatever you think of Musk, there is surely no argument about the monumental scale of what he has achieved in his lifetime. During his appearance on SNL, Musk revealed that he has Asperger's syndrome. This condition, more correctly termed autism spectrum disorder, has to be given some weighting in our evaluation of his life and work, both in terms of how his mind operates, but also in what he has had to negotiate to achieve greatness. In this biography, we have repeatedly seen a man following logic, risk, and ambition wherever they take him, along the way acquiring the knowledge and doing the work to get the job done. As things stand, a significant part of all our futures could in some way be connected to the achievements of Elon Musk. Elon Musk, Innovator, Entrepreneur, and Visionary, by Chris McNabb, narrated by Jeff Sugiyama. Text copyright Arcturus Holdings Limited 2022. This recording is copyrighted Arcturus Publishing and ID Audio 2022. The bibliography of this book is available to download in the accompanying PDF.